Now let's see about stacks. A stack is a linear data structure. That means in a stack all the elements are arranged in linear fashion one by one. A stack can be defined as a collection of items where insertion and deletion operations are done from the top end. We can represent a stack like a bucket format. So this is nothing but the arithmetic representation of a stack. So let the stack contain some 3 elements. Let the first element is 10, the second element is 20, third element is 30. So we can perform insertion and deletion operations from top of the stack. So this is nothing but top. So top always points to the top element of the stack. So the definition for the stack is: a stack is defined as a collection of items in which we can perform insertion and deletion operations from the top end of the stack. Okay, so this top is nothing but a variable which always points to the top of the stack. Now let's see the operations of the stack. Mainly we can perform 3 operations on the stack, 4 operations. First one is push operation, second one is pop operation, third one is peep operation, P-E-E-P, peep operation, and the fourth one is display operation. So mainly we can perform 4 operations on the stack. So push operation, pop operation, peep, P-E-E-P, peep operation, and the fourth one is display operation. So first let's see what is push operation. So push means inserting an item into the stack. Pop means deleting an element from the stack. Whereas peep means displaying the topmost element of the stack. Next one is display. So with the help of display function, we can display the elements of the stack from top to some 0th index. Stack works on the principle of LIFO. LIFO stands for last in, first out. Last in, first out means the element which is inserted last into the stack will be deleted first from the stack. So here in stands for insertion, out stands for deletion. So the element which is inserted last into the stack will be deleted first from the stack. So let me have a stack like this, and let us perform 3 insertion operations, 3 push operations. So first let 10 is inserted into the stack, next to 20 is inserted into the stack, next to 30 is inserted into the stack. So if you want to perform deletion operation, that is nothing but pop operation, then the element which is inserted last will be deleted first from the stack. So out of 10, 20 and 30, so 30 is the last element which is inserted into the stack. So first 30 will be deleted from the stack. Next, let us perform deletion operation one more time. So what is the, now stack contains 2 elements, 10, 20. So the last element which is inserted is 20. So now 20 will be deleted from the stack. So LIFO means last in, first out. So the element which is inserted last into the stack will be deleted first from the stack. Now let's see some examples for this stack. So the first example is a pile of books. Pile means a collection of books. Let me arrange as 3 books. This is the first book, and this is the second book, and this is the third book. Okay. So the book which is placed last will be deleted first. So what is the last book we places? This book. So this book will be deleted. This book will be removed first. Next, what is the next book we places? This book. So this book will be next deleted from the corresponding book list. Okay. So this is one example. And the second one is bangles in a lady's hand. Okay. So the bangle which is inserted last will be deleted first from the corresponding lady's hand. And the next one is coaches of a train. So let me have coaches like this. So this is the first coach, and this is the second coach, and this is the third coach. So the last coach will be deleted first. So this is about the various examples of. Now let's see the implementation of the stack. We can implement stack in two ways. First one is stack using arrays. Second one is stack using linked list. So in this class we will try to discuss how to implement stacks using arrays. In the next video we will see how we are going to implement stack with the help of the linked list. So let's see the first implementation. So implementation of stack using arrays. Implementation of stack using arrays. So there are some problems with implementation of stacks with arrays. In order to overcome that problem, we implement stack with the help of the linked list. Here, in order to implement the stack with the help of the arrays, so first we have to define a macro. Here the name of the macro is size. So hash define, let macro name is size. We need to specify macro name in uppercase letters and let the size of the stack is 5. So the major advantage of macro is throughout the program the value of size is 5 only. So it's not possible to change the value of this constant. So that is the advantage of this macro constant. Okay. Next here we are implementing stack with the help of the arrays. Let us take integer array. So int, let name of the array is stack of. So the maximum size of the stack here is size. So this size will specifies the size of this stack. So the maximum number of elements that we can store in the stack. In this example, the size of the stack is 5. We know that the index of an array starts from 0 and continues up to size minus 1. So here the size will start from, the index will start from 0 and continues up to size minus 1, 5 minus 1. That is nothing but 4. Let's implement the operations one by one. So we know that we can perform mainly 4 operations on the stack: push operation, pop operation, peep operation and display operation. Now let's see the first operation. So what is the first operation? Push operation. Push operation. So we know what is push operation. Push means inserting an element into the stack. We can perform push operation from the top end of the stack. Here initially we have to declare a variable called top, and the initial value of the top is -1. This top is an ordinary integer variable which always points to the top element of the stack. If top is equal to -1, then we can say that the stack is empty. The stack is empty. So let us perform the push operation. We know that here we can perform push operation only when the stack is not full. If the stack is not full, if the stack is full, then it is not possible to perform the push operation. So here we can have two cases. The first case is when the stack is full, and the second case is when the stack is not full. So if the stack is full, then it is not possible to perform the push operation. So simply we have to display the message as stack is full. If the stack is not full, then we can perform the push operation. So let's write some diagram for the stack. So this is the diagram for the stack. So what is the initial value of the top? -1. What is the size of the stack? 0. Here in order to perform the push operation, first we have to increment the top. Why? Because we know that the index of an array will start from 0 and continues up to size -1. So and continues up to 5 minus 1, that is nothing but 4. So first we have to increment top. What is the initial value of the top? -1. So -1 plus 1 means 0. So now top will be at 0th position. So this is nothing but top now. Now we have to read a value. Let the items of the stack are 10, 20, 30, 40, 50. Next, what is the name of the stack? Stack. So stack of, what is the index here? top. So in stack of 0, we have to store the element. So let the element is 10. So 10 will be stored here. So now what is the topmost element? 0. So this is nothing but top value. Now let us perform push operation one more time. So in order to perform the push operation, first we have to increment top value. So now top will be at 0 plus 1 means 1. So now top will be at 1 index. Let the element now is 20. So 20 will be stored in this stack of 1. So now 20 will be stored here. Next, let us perform push operation one more time. So in order to perform the push operation, what we have to do? We have to read a element. Let the element is 30. Next, increment top. What is the previous value of the top? 1. So now top will become 2. Top will become 2. Let the element is 30. So 30 will be inserted into the stack. Let us perform push operation one more time. So now, so first we have to read the element. So let the element is 40. Next to top plus plus. So now top will become 3. So insert 40 into the stack. So here, what is the range of an array? Index of an array will start from 0 and continues up to size minus 1. Here what is the size? So 5. So 5 minus 1 means 4. So the last element which we inserted into the stack will be stored at index 4. So let us perform push operation one more time. So top will be incremented by 1. So now top will become 4. So top will be at 4. Let the element is 50. So 50 will be inserted into the stack. Okay. Now, is it possible to perform insert operation or push operation one more time? It's not possible. Why? Because in this example the size of the stack is 5. So we can insert only 5 elements into the stack. So first element, second element, third element, third element, fourth element, fifth element. So likewise we can insert only 5 elements into the stack. So now what is top value? 4. Okay. What is the size here? 5. So when we can say that the stack is full? What is top value here? 4. What is size? 5. So 5 minus 1 is nothing but 4. So we can say that if top double is equal to size minus 1. So what is the top value? 4. What is the size value? 5. So 5 minus 1 means 4. So if top double is equal to size minus 1, then we can say that the stack is full. Else perform the operations. Okay. So let us write the code here. So here we have two cases. The first case is when the stack is full, and the second case is when the stack is not full. So let us write the code for push. If top double is equal to size is a constant, macro constant, so write in uppercase letters, size minus 1, then printf stack is full. Stack is full. This can be written as overflow. Stack is overflow. Let's see what is overflow. When the stack is full, then if we try to insert an element into the stack, then overflow will occur. So when the overflow will occur, if we try to insert an element into the stack when the stack is full. So what is the body here? If top double is equal to size minus 1, printf stack is full or overflow. Else, so what are the statements we have to write? So first we have to increment top value. So that can be written as top is equal to top less 1. Next, read an element. So printf enter an item. Printf enter an item to be inserted into the stack. Next, scanf %d comma ampersand item or some element. So EL is nothing but an integer variable. Next, we have to insert the corresponding element into the stack. So the statement is stack of top is equal to EL. Now let's check whether our logic is correct or not. Okay. Let's check whether our logic is correct or not. So what is the initial value of the top? -1. Next, if top double is equal to size minus 1. So minus 1 is double is equal to, so what is the size? 5. So 5 minus 1 means 4. So minus 1 double is equal to 4. Condition is false. So else block will be executed. So top is equal to top plus 1. So what is the initial value of the top? Minus 1. So minus 1 plus 1 means 0. So now top will be at 0th position, 0th index. Printf, enter the element. Let the element is 10. Next, stack of top is equal to ELE. So what is the element? 10. So 10 will be stored here. Stack of what is top? 0. So stack of 0. So 10 will be stored here. Let us perform push operation one more time. If top double is equal to size minus 1. So what is the top value now? 0. 0. So 0 is double is equal to 4. Condition is false. So else block will be executed. So top is equal to top plus 1. What is the previous value in top? 0. So 0 plus 1, 1. So now top will be at 1 index. Printf, enter the element. Let the element is 20. Stack of top is equal to ELE. So what is the ELE? 20. So 20 will be stored at stack of 1. Next 2. Let the element is 30. Next 3. Let the element is 40. Next 4. Let the element is 50. So now what is top value? 4. Let us perform push operation one more time. 4. What is top value? 4. 4 double is equal to 4. Condition is true. So the message will be printed as printf overflow. That means the stack is full. So what is overflow? If we try to insert an element into the stack, when the stack is full, then overflow condition will arise. So this is about push operation. Now let us perform pop operation. Let us perform pop operation. So already we discussed about what is pop. So pop means deleting an element from the stack. Pop means deleting an element from the stack. We can delete an element from the stack only when the stack is not empty. If the stack is empty, then it is not possible to perform the pop operation. So here also we have two cases, just like push. In push, what are the two cases? When the stack is full, that is the first case. Second case, when the stack is not full. Whereas in pop operation, the first case is when the stack is empty. Second case is when the stack is not empty. So let us perform the pop operation here. Initially top is at 4th location. So what is the deleted? Let us perform pop operation. So deleted element from the stack is 50 because this is the topmost element. So this element will be deleted from the stack. Now what we have to do? Previously top is at 4. Now after deleting the 50, we have to place top at 3. That means we have to perform decrementation operation. So top minus minus. So top is equal to top minus 1. So now top will be at 3rd index. Let us perform pop operation. So what is the element here? What is the topmost element? So 40. So 40 will be deleted from the stack. Then after that we have to decrement the top value. So now top will be at 2nd location. Next, let us perform pop operation one more time. Then what is the stack's topmost element here? 30. So 30 will be deleted from the stack. 30 will be deleted from the stack. Then after that, perform the decrementation operation of the top. So top points to the 1. Now 20 will be deleted from the stack. Now top is at 0th location. Now what will happen? 10 will be deleted from the stack. So now top will become 0 minus 1. That is nothing but minus 1. So we can say that when the stack is empty, if top double is equal to minus 1, then we can say that the stack is empty. So if top double is equal to minus 1, then print the message as stack is empty or underflow. Stack is underflow. Underflow means if the stack is empty, then if we try to delete an element from the stack, then underflow condition will arise. So what is underflow? Whenever the stack is empty, then if we try to delete an element from the stack, then underflow condition will arise. So let us write the code for pop operation. So here the first case is stack is empty. So when the stack is empty, if top double is equal to minus 1, then printf stack is empty. Stack is empty, or we can write as underflow. So what is underflow? Underflow means if the stack is empty, then if you try to delete an element from the stack, then underflow will arise. Else, so display the element. So printf deleted element from the stack is percentage d comma. So we have to delete the stack's topmost element. So name of the array is stack and the variable name is top. So stack of top. Next, what we have to do? We have to decrement top. So top is equal to top minus 1. So let we have 3 elements in the stack. So 10, 20, 30. 10, 20 and 30. So now top will be it. Top always points to the top element of the stack. So what is the topmost element index here? 2. So now top means 2. Okay. So let us perform the pop operation now. If top double is equal to minus 1. So what is top value? 2. So 2 double is equal to minus 1. Condition is false. So else block will be executed. So deleted element from the stack is, so what is the topmost element? 30. So 30 will be printed. Top minus minus. What is the previous value of top? 2. So 2 minus 1 means 1. So now top will be it. 1 index. So let us perform pop operation. Now let us perform pop operation one more time. Let's check the condition. Top double is equal to minus 1. So top value is 1. 1 double is equal to minus 1. Condition is false. So else block will be executed. So deleted element from the stack is percentage d comma stack of top. So what is stack of 1? 20. So 20 will be printed. And after that top is equal to top minus 1. So 1 minus 1 means 0. So now top points to 0. Let us perform pop operation one more time. If top double is equal to minus 1, so top value is 0. So 0 double is equal to minus 1. Condition is false. So else block will be executed. So deleted element from the stack is percentage d comma stack of top. So top value is 0. So stack of 0 means 10. So 10 will be printed. Next to top is equal to top minus 1. So the previous value of top is 0. So 0 minus 1 means 1. So now top is equal to minus 1. So let us perform pop operation one more time. So top value minus 1. So minus 1 double is equal to minus 1. So stack is empty or underflow message will be printed on the monitor. So in this way we can perform pop operation. Now let us perform peep operation. So let's see what is peep. Peep means displaying the topmost element of the stack. So peep operation. Displaying the topmost element of the stack. After displaying, there is no need to decrement top value. That is the major difference between pop and peep. So what is pop? We have to display the topmost element, and after that we have to decrement the top value. Whereas in peep operation, we have to display the topmost value, and after that there is no need of decrementing top value. Okay. So before displaying the stack's topmost element, we have to check whether the stack is empty or not. If the stack is empty, then it is not possible to display the topmost value. So how to check whether the stack is empty or not? We know that the stack is empty whenever the top value is minus 1. So here the logic is very simple. If top double is equal to minus 1, then printf stack is empty or underflow. Else display the stack's topmost element. Printf topmost element is equal to topmost element is percentage d comma. So name of the array is stack. Display the corresponding index position. So stack of top. So let me have let the stack contains 3 elements. So 0, 1, 2. Let the elements are 10, 20, 30. So what is top value now? 2. So 2 double is equal to minus 1. Condition is false. So else block will be executed. Topmost element is percentage d comma stack of top. So what is top value 2? So what is stack of 2? 30 will be printed on the monitor. So in this way we can perform peep operation. So peep means displaying the stack's topmost element. Okay. And the last operation is display operation. Here we have to perform the display operation by displaying the elements from top to 0. From top to 0th index. Okay. So let me have 5 elements here. So 4th element is 40 and the 5th element is 50. Okay. So when we can perform display operation, if the stack is not empty, then only we can perform the display operation. So when the stack is empty, if top double is equal to -1, then we can say that the stack is empty. Yes, display the values. So how we have to display the values? From top to 0. So we need to declare a variable called I. So for I is equal to top, semicolon. Here we have to display 0th element also. So the condition is I greater than or equal to 0. After displaying 4th element, we need to display the odd element. After that, we need to display 2 element. So every time we have to decrement I value. Next to printf, %d/t comma. So name of the array is stack of index variable is I. So let's check whether our logic is correct or not. So what is the top value? 4. 4 double is equal to -1. Condition is false. So else block will be executed. So for I is equal to top. So what is the value? 4. 4 greater than or equal to 0. Condition is true. So stack of 4 will be printed. What is stack of 4? 50 will be printed. I minus minus. So I will become 3. 3 greater than or equal to 0. So 40 will be printed. Next 2 greater than or equal to 0. 30 will be printed. 1 greater than or equal to 0. 20 will be printed. 0 greater than or equal to 0. 10 will be printed. Next I becomes -1. -1 is greater than or equal to 0. Condition is false. So the control comes out from the else block. So in this way we can implement stack using arrays. Now let's see about implementation of stacks using linked list. We know that stack is a linear data structure and stack can be defined as a collection of items in which we can perform insertion and deletion operations from the top end of the stack. We can implement stack using 2 approaches. The first one is implementation of stacks using arrays. The second one is implementation of stacks using linked list. So already in the last video we have seen about how to implement stacks using arrays. The major disadvantage of stack implementation using arrays is we must know in advance regarding the size of the array. How many elements we have to be stored in the array. Let us assume that we declared the size of the array as 5, and at the runtime let us assume that we want to use more than 5 elements. Then it is not possible. That is the drawback of arrays. Okay, if the size of the array is declared, then it is not possible to increase or decrease the size during the runtime. We can overcome that problem with the help of linked list. Now let's see about how we are going to implement stacks using linked list. Here we are using a single linked list in order to implement the stack. We know that a single linked list is a collection of nodes where each node contains 2 fields: data field, next field. Data field contains data value. Data value may be either integer or float or character or string or some combinations. And address field contains, next field contains address of the next node. The last node next field contains null value. Null indicates the end of the linked list. First let's see the node representation. So we know that here we can define the structure with the help of a keyword called struct. Let the name of the structure is node. Here we are using single linked list. So here we can have some data field as some integer and next field. So struct node star next. So this next field contains address of the next node. Here mainly we are using 3 structure variables. First one is star new. Second one is star toss. Here toss stands for top of the stack. Toss stands for top of the stack. Next one is star temp. So mainly we are using 3 structure variables: new, toss, temp. New for allocation of the memory. Toss top of the stack. It always points to the top node of the stack. And the next one is temp. Temp for traversing from one node to the another node. And we know that on stack we can mainly perform 4 operations. First operation is push operation. Second one is pop operation. Third one is peep operation. Fourth one is display operation. So push means inserting an item into the stack. Pop means deleting an item from the stack. Peep means displaying the topmost element of the stack. And display, with the help of display function, we can display the values from the top of the stacks to least element. Now let's see about how we are going to perform push operation. So push operation. Here the logic is very simple. First we have to allocate memory for new node. First we allocate memory for new node. Here the node contains two fields. The first field is data field and the second field is next field. Let the address of this node is 1000. So this is the first step. Allocate memory for the node. Next, read a value, store value in data field and store null in next field. Let the value is 10. Next, store null in next field. Okay. So this is the first step. Next we have two cases. The first case is if the list is empty. That means if the stack is empty. And the second case is if the list is not empty. That means if the stack is not empty. Here already we declared three structural variables: star new, star head, and star toss and star temp. So the default initial values are 0. Why? Because that node was defined on top of the main function. If you declare a structural variable on top of the main function, then the default initial values are garbage values. So new initial value, garbage value, and after that 1000 will be stored. Okay. Next, head initial value, head default initial value, head means toss. Toss default initial value is null. Temp default initial value is also null. So initially the toss initial value is null. If toss initial value is null, then we can say that the stack is empty. So if the stack is empty, then we have to place, then we have to make this node as the top node. So we have to place toss here. So if toss double is equal to null, then toss is equal to null. So we need to place toss here 1000 memory location. So the meaning of this node is, so we have a stack, and what is the first element here? 10. So 10 is stored at some 1000 memory location. Okay. So then after that we have to store the next element on the top of the 10. That means here we have to store 20. So that means here let us create one more node here. So how to create a node? We can create a node with the help of the new. So the previous value of new is 1000. So now let new value is 2000. So it has two fields. First field is data field and the second field is 20. So on top of 10 we have to store 20. So that's why onto the left of this node we have created this node. Okay. Then after that we have to read a value, store value in data field and store null in next field. So let the value is 20 and next store null here. Next what we have to do? We have two cases. The first case is if the stack is empty and the second case is if the stack is not empty. So when we can say that the stack is empty, if toss is null, then the stack is empty. If toss is not equals to null, then we can say that the stack is not empty. But here what is toss value? 1000. So that means toss is not null. So we can say that the stack is not empty. So now what we have to do is we have to establish a connection from this node to this node by storing toss address in new next field. So if we store 1000 here, then a link will be formed from new node to the toss node. Next, after inserting 20 into the stack, what will happen? Let this address is 2000. So this 2000 will become top now. So we have to place toss at new. So here the statement is toss is equal to new. Toss is equal to new. So in this way we can perform the push operation. Okay. So what is the first statement? First we allocate the memory for the node. Then after that store value in data field, store null in next field. Next we have two cases. If the stack is empty and if the stack is not empty. If the stack is empty, then we have to place toss at new node. Otherwise establish a connection from new to the toss. So let us write the code for push operation. So new is equal to, so first you allocate the memory. So struct node star malloc of size of struct node. Malloc of size of struct node. So what will happen now? A node will be created like this. Name of the node new. Let the address is 1000. So it has two fields. Data field, next field. Next, read a value. So printf enter a value. Printf enter a value. Next statement, scanf %d comma ampersand value. So let the value is 10. So next what we have to do? We have to store value in data field. So new arrow data is equal to value. Next, store null in next field. So new arrow next is equal to null. So store value in data field and store next in null field. Next we have to check whether the stack is empty or not. So when the stack is empty, if toss double is equal to null, then we can say that the stack is empty. The default initial value of the toss is null. So we can say that the stack is empty. So what we have to do? We have to place toss at new. So what is new? 1000. So place toss at 1000. Else, so when this else block will be executed, if the stack is not empty, that means if you perform push operation one more time. So create one more node. So name of the node is new. So this will be erased and you will be at 2000 location. Next, read a value. Let the value is 20. Next, store value in data field. Store null in next field. Okay. Next, check whether the stack is empty or not. If toss double is equal to null, what is toss now? 1000. 1000 double is equal to null. Condition is false. So else block will be executed. So what we have to do now? We have to establish a connection from new to the toss. So store toss address in new next field. So new arrow next is equal to toss. New arrow next is equal to toss. Next, this node will become the top node now. So place toss at new. So toss is equal to new. So what is new? 2000. So toss will be placed at 2000 memory location. Let us perform push operation one more time. So what will happen? First memory will be allocated. So allocate the memory. So name of the node new. So this will be erased. So 3000. So we have two fields. Next, store value in data field. Let the value is 30. Next, store null in next field. Store null here. Next, check whether the stack is empty or not. What is toss value? 2000. 2000 double is equal to null. Condition is false. So else block will be executed. So establish a connection from new to the task. New arrow next is equal to task. What is toss? 2000. So in place of null, store 2000. So that a link will be forward from new to the task. Next, task is equal to new. So task will be placed at 3000 location. So in this way we can perform push operation. Here we are performing the push operations using linked list. So there is no need to check whether the stack is full or not, because the stack's full condition doesn't arise here. Why? Because we are using linked list. Now let us perform pop op. Now let's see about pop operation. Let me have a stack with 3 nodes. Let the address of the first node is 3000. Address of the second node is 2000. Address of the third node is 1000. Let data of this third node is 10. We know that the last node next field contains null value. So data of this node is 20. And here we have 2000. 1000. It contains address of the next field. So next field address is 1000. So that a link will be established like this. And let the data of this node is 30. Let address of, what is the address of this node? 2000. So if we store 2000 here, then a link will be established like this. And top of the stack will point to the 3000 location. So here the stack is like this: 10, 20, 30. So what is the topmost element? 20. So we know what is pop operation. We have to delete the stack's topmost element from the stack. So what is the topmost element here? 30. So we have to delete this 30 from the stack. And after that we need to decrement the top. So here we have to delete this 30 from the stack and move toss one position to the right. So after deleting this node from the stack, so toss should point to the 2000 location. So for that initially we need to place a variable called temp at TOS. So here the statement is temp is equal to TOS. So temp will be placed at TOS, that is nothing but 3000. Then after that display the data. Printf deleted item is percentage D comma. So what is the name of the node? toss. So toss arrow data. So 30 will be printed on the monitor. Then after that, after deleting this node has to become the next node. So we have to move to its next node. So we can move to the next node with the help of toss arrow next. So toss is equal to toss arrow next. So what is toss here? 3000. 3000 next means 2000. So toss will be placed at 2000 now. Next we have to break this link now. So place null here and destroy the memory. So we can write the statements as temp arrow next is equal to null. Next, in order to destroy the memory, we use this free function, free of temp, so that we can use this memory for storing some other data. So in this way we can perform pop operation from the stack. Now let's see the next operation. The next operation is peep operation. So we know what is peep operation. So peep means displaying the stack's topmost element from the stack, and after displaying there is no need of any changing the toss value. Okay, so let we have so here the operation is peep operation. So peep operation. So let we have 3 nodes here. 3 nodes. So this is the topmost node. Let the data here is 30, 2000. So same list here, same stack here. So TOS. Okay. Here before that we can write one condition, that is in pop operation. Before that we can write one condition. If TOS is double is equal to null, printf stack is empty, else we have to write this code. Why? Because when TOS is null, if the stack is empty, then the TOS value is null. So if TOS is null, then print the message as stack is empty or stack is underflow. Why? Because if the stack is empty, then it is not possible to delete any data from the stack. Else perform this operation. Okay. Now let's perform the peep operation. Here also we have to write the same condition. If TOS double is equal to null, then it is not possible to display the data. Why? Because the stack is empty. So printf stack is empty, else display the stack's topmost data. Else printf topmost element is percentage D comma, so toss data, percentage D comma, so toss arrow data. So what is toss arrow data? 30. So in this way we can perform the peep operation. Now let's see the last operation. The last operation is displaying. So we have to display the elements from the topmost element to this last element. So here we have to display the output as 30 arrow, 20 arrow, 10 arrow. So this arrow specifies there is a link from one node to the another node. Okay. So let's see how we can perform the display operation. Here we need to place temp at toss. So here the first statement is temp is equal to toss. Here also, if the stack is empty, then it is not possible to perform the display operation. So if toss double is equal to null, printf stack is empty, else perform the display operation. Else initially temp is at toss, so we have to repeat the loop as long as this temp is not equal to null. So if temp is not equal to null, then display the corresponding data. So whenever temp equals to null, then we have to come out from the loop. So here the logic is while temp is not equal to TOS, while temp is not equal to null, printf percentage D arrow comma temp arrow data. So here for traversing we are using temp. Next we have to move to the next node. So for that purpose we are using a statement called temp is equal to temp arrow next. So let's check whether our logic is correct or not. So temp is equal to toss. So temp will be placed at 3000 memory location. If toss double is equal to null, but what is toss? 3000. So 3000 double equal to null. Condition is false. So else block will be executed. while temp is not equal to null. So what is temp? 3000. So 3000 is not equal to null. Condition is true. So this body will be executed. Printf percentage d arrow comma temp arrow data. So what is temp? 3000. 3000 data means 30. So after 30 this arrow will be printed. Next, temp is equal to temp arrow next. So temp means 3000. 3000 next means 2000. So now temp will be placed at 2000 memory location. So once again condition will be checked. While temp not equal to null, 2000 is not equal to null. Condition is true. So what is 2000 data? 20. After 20 this arrow will be printed. Next, temp is equal to temp arrow next. So temp means 2000. 2000 next means 3000. So temp will be placed at 1000. Okay. 2000 next means 1000. So temp will be placed at 1000 now. So once again condition will be checked. Why temp not equal to null? So what is temp? 1000. So 1000 is not equal to null. Condition is true. So what is 1000 data? 10 arrow will be printed. Next, temp is equal to temp arrow next. So 1000 next means null. So now temp is null. So while null not equal to null, condition is false. So the control comes out from the loop. So in this way we can implement stack with the help of the linked list. Now let's see about arithmetic expressions and applications of stacks. Let's see what is arithmetic expression. We know that an expression is a combination of operators and operands. An expression is a combination of operators and operands. Operator is a symbol which performs operations on operands. Here operand may be some variable name or value or some expression. Let's take an example. A plus b, 2 plus 3, 4 into 5 plus 7 into 8. So this is an expression which contains operators and operands. Here plus is operator, whereas a, b are operands. So that means in this example operands are variables. Let's see another example. So this is an expression which contains operators and operands. Here plus is operator, whereas 2 and 3 are operands. So here operand is nothing but a value, a number. Now let's see this example. Here operator is nothing, expression is nothing but combinations of some operators and operands. Here plus is an operator, whereas this is one operand and this is another operand. So this operand is an expression, this operand is also expression. So what is operand? It may be either a variable name or a value or an expression. Okay. Now let's see, there are three types of expressions. Expressions are classified into three types. The first one is infix expression. First one is infix expression. Second one is prefix expression. Prefix expression can also be known as polish notation. Polish notation. And the third one is postfix expression. Postfix expression can also be known as reverse polish notation. Reverse polish notation or suffix notation also. Suffix notation also. So there are mainly three types of arithmetic expressions are available. First one infix expression, second one prefix expression or polish notation, third one postfix expression or reverse polish notation. In short we can call as RPN, reverse polish notation or suffix notation. First let's see the first one, infix expression. In means middle. If an operator appears between the operands, then it is called as infix. So operator appears between the operands. Here plus is an operator which appears between operands A and B. So this is known as infix expression. Now let's see what is prefix expression. Prefix means first. That means operator appears first. Okay. First operator appears and after that we can have operands. So prefix means if an operator appears before the operands, then it is called as prefix expression. And the next one is postfix or reverse polish notation or suffix. Postfix means last. So that means operator appears after the operands. So if operator appears after the operands, then it is known as postfix expression. So what is infix expression? Operator appears between the operands. Next, prefix expression. operator appears before the operands. Postfix expression, operator appears after the operands. Okay. Next here we have several applications for the stack. So let's see those applications. Applications of stacks. Applications of stacks. Mainly we have 4 applications. The first application is evaluation of postfix expression. Evaluation of postfix expression. Postfix expression. And the second application is converting infix to postfix expression. Converting infix to postfix expression. Third application is balancing symbols. Balancing symbols, or we can also know as symbols are nothing but some delimiters. So delimiter matching. Delimiter matching. And the last one is recursion. Implementation of recursion. So evaluation of postfix expression. Next to converting infix expression to postfix expression. Next one balancing the symbols or delimiter matching. And the next one is recursion. Next in the upcoming videos we will see about all these 4 applications. So in the first video we will see evaluation of postfix expression. In the second video we will see how we can convert infix to postfix expression with the help of some example. Next in each video we will have example, algorithm as well as a program. Okay. What is the third one? Balancing symbols or delimiter matching. And the last one is recursion. Okay. In this class we will discuss about algorithm for evaluation of postfix expression and 2 examples which demonstrates how we can evaluate postfix expression as well as a C program for evaluating postfix expression. First let's see about the algorithm. Here we have 4 steps. First step, read postfix expression from left to right. So we have to read the postfix expression from left to right. That means from 0th character to size -1. Second one, if the reading character is an operand, then push the operand onto your stack. So we know what is an operand. An operand may be either a variable or a number. So if the reading character is a number or a variable, then push the operand onto the stack. So if the symbol is an operand, then we have to push the number onto the stack. Next step, if the reading character is an operator, then pop topmost 2 elements, consider them as OP2. The first operand is OP2, whereas the second operand is OP1. Perform the operation on OP1 and OP2. So here we have to perform operation on OP1 and OP2 based on the operator and push the result onto the stack. Okay. So here the point is very simple. Let the stack contain some numbers like this 10, 20, whereas we read some minus. So if the reading character is an operator, then we have to pop the topmost 2 operands. So here we have 2 operands. Let the stack contains some more operands like this. So 5, 6. So here if the reading character is an operator, then what we have to do? We have to pop the topmost 2 operands. But consider the first one as OP2. So OP2 is equal to 20. Next, pop the second operand. What is the second operand? 10. Consider it as 10. And perform the operation on OP1, OP2. What is the operation which we have to perform? Minus. So OP1 minus OP2 means 10 minus 20. So 10 minus 20 means minus 10. And then push this result onto the stack. So here what is the point here? If the input symbol is an operator, then we have to pop the topmost 2 operands from the stack. Consider the first operand as OP2, second operand as OP1. but we have to perform the operation as OP1 operator OP2, not perform the operation OP2 minus OP1. Okay, OP2 operator OP1. So which operation we have to perform? OP1 minus OP2, OP1 plus OP2, OP1 star OP2, like that. Okay, and then push the result onto the stack. And last step, after processing the entire postfix expression, now the result is available in the top of the stack. Okay, after processing the entire infix expression, after processing the entire postfix expression, so then what will happen is the stack contains only one element. So that element is nothing but the result of evaluating that postfix expression. So here we have simply 4 steps. First step, read the postfix expression from left to right. Second step, if the character is an operand, then push it onto the stack. And the third step is, if the character is an operator, then pop the topmost 2 operands. Let the first operand is OP2, second operand is OP1, but perform the operation as OP1 operator OP2 and push the corresponding result onto the stack. And the last step is, after processing the entire postfix expression, the result is available in the stack. Okay, now let's see an example. Let's see 2 examples for evaluation of the postfix expression. Now let's see 2 examples for evaluating postfix expression. So this is our first example, 6523 plus 8 asterisk star operation plus 3 plus asterisk. Okay, so what is the first character? 6. So this is nothing but our stack, whereas this is nothing but our postfix expression. Okay, so what is the first one? First character, operand, number. So if it is an operand, then we have to push the result onto the stack. So push 6 onto the stack. Okay, second one, 5. So what is 5? 5 is also an operand. So if the character is an operand, then we have to push the operand onto the stack. So next operand, 2. So what is 2? 2 is an operand. So push the operand onto the stack. So next one, 3. So what is 3? 3 is also an operand. So push the operand onto the stack. Next one, plus. What is plus? Operator. So if it is an operator, we have to pop the topmost 2 operands. So we have to pop this operand as well as this operand. But we have to assume the first operand as OP2. So what is OP2? OP2 means 3. And the next operand as OP1. So what is OP1? 2. So pop these operands and perform the operation plus. So which operation we have to do? OP1 plus OP2. OP1 plus OP2. So what is OP1? 2. What is OP3? 3. So 2 plus 3, 5. And push the result onto the stack. Okay. And what is the next operand? 8. So what is 8? 8 is an operand. So push the result onto the stack. Next operand, star. So what is star? Star is an operator. So we have to pop the topmost 2 operands. So we have to pop 8 as well as 5. So we have to consider the first one as OP2. So OP2 means 8. And second one as OP1. So what is OP1? 5. So pop this operand also and perform the operation. So which operation we are performing? Star. OP1 star OP2. So 5 into 8 means 40. So push the result onto the stack. So we have to push 40 onto the top of the stack. Next one, plus. Plus is an operator. So what we have to do? We have to pop the topmost 2 operands. So we have to pop 40 as well as 5. So consider the first one as OP2. So OP2 means 40. And consider the second one as OP1. So OP1 means 5. Okay, OP1 means 5. And perform the operation. So which operation we have to perform here? Plus. So OP1 plus OP2. So 5 plus 40. So 5 plus 40 means 45. 5 plus 40 means 45. So push 45 onto the stack. So what is the next operand? 3. Next character 3. 3 is an operand. So push the result onto the stack. So next one, plus. What is plus? Plus is an operator. So we have to pop the topmost 2 operands. So first operand 3. So 3 should be stored in OP2. Next operand 45. So 45 should be stored in OP1. So perform the operation. So which operation we have to perform? Plus. So OP1 plus OP2. 45 plus 3, 48. So push the result onto the stack. So what is the next one? Asterisk. So pop the topmost two operands. So pop 48, 6. So now OP2 will become 48. OP1 will become 6. Perform the operation OP1 into OP2. So 6 into 48. So what is 6 into 48? So 6 8s are 48. 6 4s are 24. So 24 into 8, 288. So push the result onto the stack. So now the stack contains how many elements? Only one element, that is 288. So the entire postfix expression is processed. So now we have to pop the stack. So if you pop the stack, what is the result which we have? 288. So 288 is nothing but result of the stack. Okay, 288 is nothing but result of the stack. Here we have to place this expression in. This is nothing but postfix expression. 6523 plus 8 star plus 3 plus star. This is nothing but postfix expression, and we are pushing the operands onto the stack. Okay. Now let's see the second example. So what is the result of the this first expression? 288. Now let's see the second example. 723 plus minus 382 division plus asterisk 2. This is nothing but power symbol. In the examination, power symbol will also be given as this up arrow. Power symbol can also be given as this up arrow. Power means 2 power 3 means 8, 5 square means 25, like that. Okay, power or up arrow. Okay, next 3 plus. Okay, and now in order to evaluate this expression, we have to take a stack. Okay, so let us take the stack now. So what is the first character? Operand. So push. Next one 2, operand. So push. Next one 3. 3 is an operand. So push. Next one plus. So if it is operator, what we have to do? We have to pop topmost 2 operands. The first operand is OP2. So OP2 means 3. Next to the second operand is OP1. So OP1 means 2. So which operation we have to perform? Plus. So OP1 plus OP2. So what is OP1? 2. So 2 plus 3 means 5. So push 5 onto the stack. Okay. So next one minus. So minus is an operator. So what we have to do? We have to pop the topmost 2 operands. So OP2 means 5. OP1 means 7. So which operation we have to perform? OP1 minus OP2. What is OP1? 7. What is OP2? 5. So what is 7 minus 5? 2. So push the result 2 onto the stack. So next one 3. 3 is an operand. So push 8. 8 is an operand. So push. Next one 2. 2 is an operand. So push. Next one division symbol. So we have to pop topmost 2 operands. So what is the first one? 2. So 2 will be stored in OP2. Next one 8. 8 will be stored in OP1. So which operation we have to perform? Division. So OP1 by OP2. What is OP1? 8. 8 by 2. So what is 8 by 2? 8 by 2 means 4. So push 4 onto the stack. So push 4 onto the stack. So what is the next one? Plus. So we have to pop the topmost 2 operands. So OP2 means 4. OP1 means 3. OP1 means 3. And which operation? Plus. So 3 plus 4 means 7. So push 7 onto the stack. So next one star. So star is an operator. So what we have to do? We have to pop the topmost 2 operands. So OP2 will become 7. Next OP1 will become 2. So next 2 into 7. So 2 into 7 means 14. So push 14 onto the stack. Okay. So what is the next one? 2. So 2 is an operand. So push 2 onto the stack. Next one power. So what is OP2? 2. What is OP1? 14. So which operation we have to perform? OP1 cap OP2. So 14 square. So what is the result of 14 square? So 14 4s are 56. That is nothing but 196. So push 196 onto the stack. So next one 3. So push 3 onto the stack. Next one plus. So pop 3 196. So 196 plus 3 means 199. So the processing of the entire postfix expression is over. Now the stack contains only one element. What is that element? 199. So 199 is the result of this expression. Now let's see a program for evaluating a postfix expression. Now let's see a C program for evaluating the postfix expression. Hash include map.h. So in this program we are using map.h. Why? Because we are using POW function, power function. This POW power function is available in math.h header file. And the next one, hash include ctype.h. Ctype stands for character type checkings. In this program we use isDigit function. This isDigit function is available in ctype.h. If you want to use functions like isAlpha, isNum, so all these functions are available in ctype.h. Next, int stack of 20. So here we are using stack for storing the numbers. So that's why we declared stack as an integer array. Next, OP1 and OP2 for storing the operands. Next, the initial value of the top is -1. So if top double is equal to -1, then we can say that the stack is empty. We know that the execution of a program starts from main function. Here we have to read the postfix expression as a string. Why? Because here a string is like this: 1 2 3 star plus 4 minus 6 star 4 5 2 3, like that. So it is not possible to read this as an integer array. So we have to take this one as a string. So char postfix of 20. Next, here in order to perform the power operation, after performing the power, we need to store it in a variable. For storing that value, we are using res variable. Next, I for repetition in the for loop. Printf enter postfix expression gets of postfix. This is our expression: 1 2 3 star plus 4 minus. So the index values are like this: 0 1 2 3 4 5 6. We know that string ends with null character. Okay. Next, for I is equal to 0. So what is I value? 0. I value 0. Postfix of 0 not equal to null. So what is postfix of 0? 1. So 1 is not equal to null. Condition is true. Next, what we have to do is here we are reading this one as a string. We are reading 1 2 3 this entire expression as a string. But we have to perform some arithmetic operations. So we have to check whether it is digit or not. If is digit of postfix of 5. What is 1? Here I means 0. So what is postfix of 0? 1. So what is 1? Is digit of 1. So 1 is a digit. So it returns true. But here 1 we give, here we have taken this one as characters. We know that the ASCII value of 0 is 48, 1 is 49, 2 is 50, 3 is 51. So likewise 9 means 57. So here the ASCII value of 1 will be returned. So what is the ASCII value of 1? 49 will be returned. Okay. So 49 will be pushed onto the stack. But which value we have to push? Either 49 or 1. Here we have to push 1 only. So that's why we have to subtract the corresponding ASCII value with 48. So what is 48? 48 means the ASCII value of 0. So if you want to get 9, what is 9 ASCII value? 57. So 57 minus 48. So 57 minus 48 means 9. So 9 will be pushed onto the stack. Okay. So push off postfix of 5. So what is postfix of I? Postfix of 1 means 1. But here 1 will be treated as a character. The ASCII value of 1 is 49. So push off postfix of 1 means 49. So push off 49 minus 48. So 49 minus 48 means 1. So push off 1. So control goes to push function. So what is x value now? 1. So top plus plus. So this is nothing but our stack. The initial value of the top is -1. Now top will become 0. So this is nothing but top. So stack of top is equal to x. So what is the value we pass here? 1. So 1 will be stored here. Okay. After executing the corresponding function, control goes to the main function. So here we call the function. Here if block is executed. So what will happen? Else block won't execute. So this is nothing but closing of else block. Else block won't execute. So control goes to I++. So this is the thing which we have to do. If the symbol is an operand, then we have to push onto the stack. Next I++. Now I becomes 1. So once again condition will be evaluated. Postfix of 1 not equal to null. So what is postfix of 1? 2. 2 is not equal to null. Condition is true. Next is digit of postfix of 5. So what is 2? It is a digit. So condition is true. But here 2 means it gives the ASCII value of the 2. That is nothing but 50. So push off 50 minus 48. So 50 minus 48 means 2. So push off 2. So control goes to the push function. Top plus plus. Now top will become 1. Okay. Next, stack of top is equal to x. What is x now? 2. So 2 will be pushed onto the stack. So likewise, what will happen? What is the next character? 3. Here, what is happened now? Function definition is executed. Once function definition executed, then the control goes to the corresponding function call. So what is the next statement here? Else. But if this condition is true, then only if block will be executed. Else block won't execute. Next, I plus plus. I becomes 2. What is 2 character? 3. Now top becomes 2. So 3 will be pushed onto the stack. So now top is at 2 location. Okay. Next, I plus plus. Now I becomes 3. Postfix of 3. What is postfix of 3? Star. Star not equal to null. Condition is true. Star is an operator. So we have to pop the topmost 2 operands. Let's see whether our logic is correct or not. So if is digit of postfix of 5. But what is postfix of 3? Star. Is star a digit? No. Star is not a digit. So this condition is false. So else block will be executed. So OP2 is equal to pop. OP2 is equal to pop. So OP2 is equal to, so control goes to the pop function. So what is the pop function? Return stack of top minus minus. So this is nothing but post decrementation operation. So during post decrementation, what will happen? First the corresponding value will be returned. So return stack of top. So what is top? Stack of 2. So what is stack of 2? 3. So OP, so the corresponding value will be returned. So stack of 2, that is nothing but 3. So 3 will be returned and it is assigned to OP2. Next, post decrementation, top minus minus. So top will be decremented now. So now top will be at 2 minus 1 means 1. So this function is executed. Next, this statement will be executed. OP1 is equal to pop. So control goes to the pop function. So return stack of top minus minus. This is post decrementation. So first value will be returned. So what is top? 1. So what is stack of 1? 2. So 2 will be returned and it will be assigned to OP1. OP1. Okay. Next to top minus minus. So 1 minus 1 means 0. So now top is at 0th location. Okay. So these two statements are executed. Next statement, switch off postfix of I. So what is postfix of I? Star. So switch off star. So here this is nothing but cases. First case within the single quotation plus. So plus means an operator, a character. If it is a character, then we have to enclose within single quotation. So case within the single quotation plus colon push off OP1 plus OP2 semicolon break. Next case minus. If it is minus, then we have to perform the operation OP1 minus OP2 and push the corresponding result onto the stack. So push off OP1 minus OP2 break. So likewise we have to write for star, division, modulo. This is nothing but cap. So in order to perform cap means power. So in order to perform that operation we have to use POW function. So POW of OP1 comma OP2, store the result in RES and push off RES break. Okay. Now what is the symbol star? So here for the space constraints I am not written star, division and modulo. Okay. So what is case star? Push off OP1 star OP2. OP1 means 2. OP2 means 3. So 2 into 3 means 6. So push off 6. So control goes to the push function. So top plus plus. The previous value of top is 0. Now top will be at 1. Top will be at 1. So 2 into 3, 6. So 6 will be pushed onto the stack. Okay. So next, switch is executed. Okay. So next what will happen? Else block execution is over. I plus plus. Now I becomes 4. I becomes 4. So postfix of 4 is not equal to null. What is postfix of 4? Plus. Plus is not equal to null. Condition is true. Is plus is a digit? No. Condition is false. So else block will be executed. OP2 is equal to pop. So control goes to pop function. Return stack of top minus minus minus. So what is stack of top? 6. So 6 will be written and it is assigned to OP2. Next to top minus minus. So now top is at 0th index. So the function execution is over. So control comes to the main program. Next function call OP1 is equal to pop. So control goes to the pop function. Return stack of top minus minus. So what is stack of top? Stack of 0. What is stack of 0? 1. So 1 will be written and it will be assigned to OP1. Next to top minus minus. Now top will be at 0 minus 1 means minus 1. Okay. So next, switch off postfix of 5. What is the operation? Plus 1 plus 6 means 7. So push off 7. So control goes to the push function, top plus plus. Now top is at 0th location. So what is the result here? 7. So 7 is pushed onto the stack. What is the next one? 4. 4 is pushed onto the stack. What is the next one? Minus. So what will happen? OP2 means 4. OP1 means 7. So 7 minus 4 means 3. So 3 is pushed onto the stack. What is the next character? Null. Null not equal to null. Condition is false. So the control comes out from the for loop. So this is nothing but end of else. This is nothing but end of for. Result is percentage d comma pop. So control goes to pop function. Return stack of top. What is the value? 3. So 3 will be returned and it will be printed here. Result is 3. Next top minus minus. So top will be at minus 1. Okay. So in this way, we can write a C program for evaluating the postfix expression. In this class, we will discuss about algorithm for infix to postfix conversion as well as 2 examples in order to convert an infix expression to postfix expression. Next, followed by a C program for converting infix expression to postfix expression. First, let's see the algorithm for converting infix expression to postfix expression. Here we know that an expression may contain operators and operands. Here expression contains some left parenthesis, right parenthesis, some operators and operands. So let's see the algorithm. First step, read infix expression from left to right. So left means 0th character. So right means n minus 1, size minus 1 character. Okay. Second step, if the symbol is left parenthesis. So here this is the left parenthesis, whereas this is the right parenthesis. This is left parenthesis, this is right parenthesis. If symbol is left parenthesis, then push it onto the stack. So if the reading symbol is left parenthesis, then we have to push it onto the stack. Next step, if the symbol is an operand, then add it to the postfix expression. We know what is operand. An operand may be a variable name or some value. Suppose if the symbol is an operand like ABC, or if the symbol is an operand like 5, 4, 3, some numbers, then we have to add it to the postfix expression. Let's see the next step. If the symbol is operator, then check if stack is empty or not. So we know what is an operator. An operator is a symbol which performs operations on the operands. So if the symbol is an operator, then we have to check whether the stack is empty or not. So next step in fourth one, A. If stack is empty, then push operator onto the stack. So if the corresponding stack is empty, then what we have to do? We have to push the operator onto the stack. So these two are very important steps here. B. If stack is not empty, then check priority of the operators. Suppose if the stack is not empty, then we have to compare priority of reading operator with stack's topmost operator priority. So let me have like this. Let the stack contains an operator called some left. We have some left parenthesis. On top of the left parenthesis, let we have plus. Let the reading operator is star. We have an expression like this. Now we have read star. Okay. Let's see the step here. If reading operator has higher priority than priority of stack's topmost operator, then push it onto the stack. Okay. So we have some priorities like left parenthesis has some 0 priority. That means left parenthesis has least priority. Okay. Next some plus minus has next least priority. Let the priority of plus and minus is 1. Next star division modulo has next priority. Okay. So star division modulo has highest priority than plus minus. So plus minus has highest priority than left parenthesis. Here 0 specifies lower priority. 1 specifies higher priority. 2 specifies higher priority than 1 and 0. Next we have some symbols like power and dollar. Okay. So power and dollar has highest priority than star division and module. Okay. So here what is the point? if reading operator has higher priority than stack topmost operator, then we have to push it onto the stack. Here what is the reading operator? Star. So star priority is 2. Whereas what is the stack topmost operator? Plus. Here plus priority is 1. So that means here star has higher priority than plus. So we can push star onto the top of the stack. So this is the step here. Next step, if priority of reading operator is less than or equal to, then if priority of the reading operator is less than or equal to priority of the operator present at top of the stack, then pop the operator. That means we have to pop the stack and add it to the postfix expression. Okay. So let us assume that here we have some operators like this. So let the stacks operators are like this. We have some star here, next to plus here. Let the reading operator is division. Okay. So what is the reading operator? Division. Whereas what is the here on top of the star we can't place plus here. Okay. Let us assume that here we have a star, here we have division. So let us assume that we have like this. Okay. So what is the stack topmost operator here? Division. Okay. Here what is the here what is the reading operator? Reading operator is division. Whereas what is the stack's topmost operator? Star. So division and star has equal priority. What is the priority for division and star? 2. Then what we have to do is we have to pop the stack and place them in postfix expression. So pop star from the stack and place them in postfix expression. Next, what is the stack's topmost symbol? Division. What is the reading operator? Division. So division. Both operators priority is same. So then also what we have to do is we have to pop this division from the stack and place them in postfix expression. Next, we have to push division onto the stack. Okay. So let us assume that here we have plus. Stack's topmost operator is plus, whereas the reading operator is division. So division has higher priority than plus. So what we have to do now? We have to pop. Here division has higher priority, so there is no problem here. Whereas let us assume that here we have plus, whereas here we have division. Stack's topmost operator is division, whereas here we have minus. Okay. So now what is the reading operator? Minus is the reading operator, whereas stack's topmost operator is division symbol. Okay. So minus has least priority than division. So we should not push minus onto the top of the stack. So what we have to do now? We have to pop division from the stack and place in postfix expression and then push minus symbol onto the stack. Okay. Okay. So here what is the point here? If reading operator has less priority than top of the stack, then what we have to do? Pop the stack and place them in postfix expression. Suppose if reading operator has equal priority with stack's topmost operator, then also we have to pop the stack. So let the reading operator is plus, let the reading operator is minus, whereas stack's topmost operator is plus. Minus plus has equal priority, so then also we have to pop the stack and then place this expression and then place this symbol in the corresponding expression, corresponding stack. Okay. So likewise we have to continue. Let's see the last step. If the symbol is right parenthesis, this is the right parenthesis, then pop all the symbols from the stack and places them in postfix expression until we get left parenthesis. But left parenthesis is popped but should not placed in postfix expression. So here what is the point? If the symbol is right parenthesis, then we have to pop all the items from the stack until we get left parenthesis. But we should not place left parenthesis in postfix expression. Okay. So let we have like this. Let the current symbol is right parenthesis. Whereas in the stack we have like this: plus, minus, some star, plus, left parenthesis like this. So here what is the So here what is the current symbol? Right parenthesis. If the symbol is right parenthesis, then we have to pop the stack and place them in postfix expression until we get left parenthesis. But pop the left parenthesis and don't place left parenthesis in postfix expression. So here the symbol is right parenthesis. So pop star from the stack and place in postfix expression. Next, pop plus from the stack and place in postfix expression. Next, left parenthesis. We have to pop left parenthesis but don't place in postfix expression. Okay. Why? Because here our postfix expression doesn't contain left parenthesis and right parenthesis. So this is the algorithm for converting infix expression to postfix expression. Now let's see two examples in order to convert infix expression to postfix expression. Okay. Here we have one more step. After completion of reading the infix expression, if the stack is not empty, then pop all the symbols from the stack and add it to the postfix expression. So let the input expression is completely processed. Let we have an expression like this: a plus b, and null. Let the reading character is null now. So that means the entire expression is processed. But top is not equal to -1 here. Why? Because here the stack is not empty. Stack contains two items here. Then what we have to do now? We have to pop the stack and place it in postfix expression. Okay. So after reading the entire infix expression, if the stack is not empty, then pop the stack and place them in postfix expression. So this is the algorithm for converting infix to postfix expression. Now let's see examples. Now let us convert these two infix expressions to postfix expression. So here we have a stack like this. Next, this is nothing but postfix expression. So this is our output expression. So what is the first character? What is the first symbol? A. So A is an operand. So if the symbol is an operand, then we have to add it to postfix expression. So place A in postfix expression. Next symbol, plus. So plus is an operator and the stack is empty. So if the stack is empty after reading an operator, so what we have to do? We have to push it onto the stack. So push plus. Next symbol is B. B is an operand. So if the symbol is an operand, then add it to postfix expression. Next one, star. So if the symbol is an operator, then check whether the stack is empty or not. But here the stack is not empty. So compare priority of reading operator with stack's topmost operator priority. So here in the stack we have only one operator, that is plus. Here star has higher priority. Star has higher priority than plus. So we can push star onto the top of the stack. Next symbol is plus. So plus is an operand. So place in postfix expression. Next one is C. C is an operand. So place in postfix expression. Next one, plus. Plus is an operator. And what is the plus is an operator? So we have to check whether the stack is empty or not. But here the stack is not empty. So compare priority of this operator with stack's topmost operator priority. So plus priority is less than star. So what we have to do? We should not place plus on top of the star. So plus priority is less than star. So pop star from the stack and place in postfix expression. Next, plus. So these two operators have equal priority. If they are equal priority operators, then also what we have to do is we have to pop the stack and place in postfix expression. Now push this symbol onto the top of the stack. So next one is left parenthesis. If it is left parenthesis, then there is no need to check any priority. Okay, irrespective of left parenthesis position, simply we have to push onto the top of the stack. Actually, left parenthesis priority is smaller than plus, but here we should not follow any priority constraints for left parenthesis. If the symbol is left parenthesis, then irrespective of any symbol in the top of the stack, we need to simply push. So push left parenthesis. And the next one is D. D is an operand. So place in postfix expression. Next one is star. But what is the stack's topmost operator? Left parenthesis. Star has higher priority than left parenthesis. Left parenthesis priority is 0 only, whereas star priority is some 2. So we can push. Next one is E. E is an operand, so place in postfix expression. Next symbol is plus. Plus is an operator. And what is the stack topmost operator? Star. Plus has less priority than star. So we should not place plus on top of the star. So delete star from the stack and place it in postfix expression. Now left parenthesis has least priority than plus. So we can push plus onto the top of the stack. Next one is F. F is an operand. So place in postfix expression. Next one is right parenthesis. If the symbol is a right parenthesis, then pop the stack and place in postfix expression until we get left parenthesis. But don't place left parenthesis in postfix expression. Why? Because postfix expression doesn't contain left parenthesis and right parenthesis. So pop plus from the stack and place it in postfix expression. Next symbol is left parenthesis. So pop the left parenthesis, but don't place left parenthesis in postfix expression. Next one is star. Here star has higher priority than plus. So push star onto the top of the stack. Next one is G. So G is operand. So push it onto the top of the stack. Now the entire infix expression is processed, completed, but the stack is not empty. So what we have to do? We have to pop the stack and pop the remaining items from the stack and places it in postfix expression. So pop star from the stack and place it in postfix expression. Next pop plus from the stack and postfix expression. So this is the corresponding postfix expression for this infix expression. Now let us convert this infix expression to postfix expression. So we have a stack like this and we have a postfix expression like this. Here left parenthesis has least priority. Next highest priority operator is plus minus 1. Next one star, division, modulo. And the next one cap and some dollar symbols. Okay. Here cap means power. So power has highest priority than star, division and plus. Okay. This power symbol has highest priority than star, division and plus. So what is the first symbol? Left parenthesis. So we have to push it onto the stack. Next symbol, left parenthesis. So push it onto the stack. Next one, A is an operand. So add it to the postfix expression. Next symbol, minus. So minus has higher priority than division. So we can, minus has higher priority than left parenthesis. So we can push minus onto the top of the stack. Why? Because what is minus priority? 1. Whereas left parenthesis is 0. So we can push minus onto the top of the left parenthesis. Next one, left parenthesis. So push it onto the left. If the symbol is left parenthesis, then irrespective of what is the topmost symbol, okay, we can push it onto the stack. Okay. Actually left parenthesis has least priority than minus. Okay. But also there is no problem here. If the symbol is left parenthesis, then irrespective of any symbol, any top symbol, then we can simply push it onto the stack. So push it onto the stack. Next one is B. B is an operand. So place in postfix expression. Next one is plus. Next one is plus. What is the stack's topmost operator? Left parenthesis. So plus has greater priority than left parenthesis. So we can push plus onto the top of the stack. Next one is C. C is an operand. So add it to the postfix expression. Next one, right parenthesis. If the symbol is right parenthesis, then pop the stack until we get left parenthesis, but don't place left parenthesis in the postfix expression. So pop plus and place it in postfix expression. Next, left parenthesis. We have to pop the left parenthesis, but don't place left parenthesis in postfix expression. Next, the second, right parenthesis. So if the symbol is right parenthesis, then pop the stack. So pop minus from the stack and place it in postfix expression. Next, pop this left parenthesis from the stack, but we should not place left parenthesis in postfix expression. Next one, star. So star has higher priority than left parenthesis. So push star onto the top of the stack. Next, D. D is an operand. So we add it to the postfix expression. Next one, right parenthesis. So pop the stack. So pop star from the stack and add it to the postfix expression. Next, pop left parenthesis from the stack, but don't place left parenthesis in postfix expression. Okay. Next one, cap, and the stack is empty. So we can simply push this cap symbol, power symbol, onto the top of the stack. Next one, left parenthesis. If it is left parenthesis, then directly we can push it onto the stack. No need to check the priority. Next, E, operand. So place it in postfix expression. Next, minus. Minus has highest priority than left parenthesis. So we can push it onto the stack. Okay, minus is over. What is the next one? F. F is operand. So add it to the postfix expression. Next one, right parenthesis. So if it is right parenthesis, then what we have to do? Pop the stack and place it in postfix expression. But don't place this left parenthesis in postfix expression. Okay. Next, so right parenthesis is over. So that means the entire infix expression is processed, but the stack is not empty. So what we have to do? We have to pop this cap symbol from the stack and place it in postfix expression. So in this way we can convert infix expression to postfix expression. Now let's see a C program in order to convert infix expression to postfix expression. Now let's see a C program to convert infix expression to postfix expression. First let's see the logic here. Hash include ctype.h. Ctype stands for character conversions. In this program we are using isAlpha function and isDigit function. These two functions are available in ctype.h. Next we declare three functions: push function, pop function and priority function. The return type of the push function is void and it accepts a character as the parameter. Here it accepts an operator as the argument. Operator is nothing but a character and the return type is void here. And next one is pop function. Pop function doesn't accept any parameters and the return type of the pop function is character here. Next, priority function accepts an operator as the parameter, that is nothing but a character as the parameter, and it returns some priority value. So int is the return type of the function. So return type of the push function is void and it accepts a character as the parameter. Return type of the pop is char and it doesn't accept any parameters. Priority function return type is integer and it accepts a character as the parameter. Next, the initial value of the top is -1. If top is -1, then we can say that the stack is empty. Next, here in order to store the symbols, in order to store left parenthesis and operators, we require a stack. So char stack of 20. So stack is a string which can store maximum of 20 characters. Next, char infix of 20. In order to store the infix expression, we are using this infix string, comma postfix of 20. And here we know that the output is postfix expression, whereas the input is infix expression. So in order to store the postfix expression, we are using this string. Next, in order to store each character, we are using a normal character called ch. Next, to perform operations on the infix expression, use a variable called I. Next, to perform operations on the postfix expression, use a variable called j. So I for infix expression, j for performing operations on postfix expression. The initial value of the j is 0. Why? Because we know that the index of an array will start from 0. Next, to printf enter infix expression gets off infix. So infix expression is the input expression here. Next, for I is equal to 0, infix of I not equal to null I plus plus. We know that the index starts from 0 and we know that the string ends with null character. So we have to repeat the loop as long as the corresponding character is not equals to null. So whenever it becomes null, then we have to quit from the for loop. So this is nothing but end of the for loop. This is nothing but end of the main function. Okay. Next, I plus plus. Ch is equal to infix of I. In order to store each character, we are using the ch. Okay. Next, if ch double is equal to left parenthesis. If the input symbol is left parenthesis, then we have to push it onto the stack. So push of ch. So control goes to the push function. So this is the push function here. Return type of the push function is void and it accepts that symbol as the argument. So in push function, what we have to do? We have to increment top value. So top plus plus and store the corresponding character in the stack. So stack of top is equal to x. Now let's see the next one. Here we use else if ladder. Else if is alpha of ch or is digit of ch. That means if the reading character is an operand, that means if it is an alphabet or if it is a number, a digit, then what we have to do? We have to add that character to the postfix expression. So if one of this expression is true, that means if the character may be either alphabet or digit, then add it to the postfix expression. So postfix of j is equal to ch. So that character should be added to perform operations on the postfix expression. We are using j. So postfix of j is equal to ch. Next, after that we have to increment j plus plus. Okay. Next, if the reading character is a right parenthesis, then what we have to do? If it is a right parenthesis, then we have to pop the stack and place the corresponding character in postfix expression until we get left parenthesis. But we should not place left parenthesis in the postfix expression. Let's see the logic here. While stack of top is not equal to left parenthesis, that means if the stack's topmost symbol is not equals to left parenthesis, as well as if the stack is not empty, then what we have to do? We have to pop the corresponding symbol from the stack and place it in the postfix expression. So postfix of j is equal to pop function. So control goes to the pop function. The return type of the pop function is cap and it doesn't accept any parameter. So return stack of top minus minus. This is post decrement operator. So first stack of top value will be returned and after that the decrementation will be done. That stack of top value will be written and it will be assigned to postfix of j. Okay. Next we have to increment j plus plus. Okay. So whenever we get left parenthesis, then what will happen? Left parenthesis is not equal to left parenthesis. So condition will becomes false. So control comes out from the while loop. So pop function will be executed. Okay. But here we don't have any left hand side variable here. Here we have left hand side variable. Why? Because we have to place that character in postfix expression. But if it is a left parenthesis, then we should not place that left parenthesis in postfix expression. That's why here there is no need of any left hand side variable. So control goes to the pop function, return stack of top minus minus. That means that left parenthesis will be returned, but it should not be assigned to the postfix expression. Okay. Next, top value will be decremented. Okay. Next, else this is for operator. While priority of ch is less than or equal to priority of the stack of the top and top not equal to -1. Suppose let us assume that the top equals to -1. That means the stack is empty. Then this condition will becomes false. So if it is an operator and the stack is empty, then what we have to do? We have to push it onto the stack. So this function will be executed. Suppose if this condition is true, that means let here we have a star here, whereas the stack topmost operator is plus. Okay. So what is the operator priority here? So 2. What is this is nothing but priority function. Int priority of char ch. If ch double is equal to left parenthesis. For left parenthesis the priority value is 0. Else if ch double is equal to plus or ch double is equal to minus. For plus and minus the priority value is 1. Return 1. So for star, division and modulo the priority value is 2. For power the priority value is 3. For power the priority value is 3. So let we have a situation like this. So let we have here, we need to perform the pop operation here. So let here we have a stack topmost operator is star, whereas here we have plus here. So priority of ch. Here this is the current reading operator. So what is the priority of the plus? 1. Where next less than or equal to priority of the stack of the top. What is the star priority here? 2. So 1 is less than or equal to 2. Condition is true and top is not equal to -1. That means here the reading operator has lesser priority than the stack's current operator. So then what we have to do? Than the stack's topmost operator. Then pop this operator from the stack and place it in the postfix expression. So postfix of j is equal to pop j plus plus. So this star will, let us assume that before star we have some other symbol like, so this star will be popped and places it in postfix expression. So let me have plus here. So plus and plus, these two operators priority is equal. So 1 less than or equal to 1. Condition is true. So if the operators are belonging to the same priority, then also we have to pop the stack and place it in the postfix expression. Okay. And after that, let we have star here. Then what will happen? Star will be popped from the stack and placed in the postfix expression. And then we need to push this symbol onto the stack. In order to perform the push, we use this push. Next, after perform, this is nothing but end of the for loop. After performing the entire operations, let the stack contain some elements. Then what we have to do is, we have to pop the stack and place it in the postfix expression. Okay. So postfix of j is equal to pop j plus plus. Next, so now the entire conversion is over. We know that every string ends with null character. So in the last character we have to place as null. So postfix of j is equal to null, then print the expression. Okay. So this is the logic here. Now let's see an example here for demonstrating this program. Of infix. So this is our infix expression. A plus b star c plus left parenthesis d star e plus f right parenthesis star g. These are nothing but some index values. We know that every string ends with null character. So the last character is nothing but null character. For I is equal to 0, infix of I not equal to 0. This is nothing but 0. So what is infix of 0? A. A is not equal to null. Condition is true. So what will happen? The body will be executed. Ch is equal to infix of 0. What is ch? A. Next, A double is equal to left parenthesis. Condition is false. A double is equal to right parenthesis. Condition is false. Okay. Next, A is an alpha bit. Is alpha of ch. Else if is alpha of ch or is digit of ch. Here A is an alpha bit, but A is not a digit. But this is logical OR. So if one of the condition is true, then the entire expression is true. So postfix of j is equal to ch. So what is A? Here initially we have taken two values I and j. I for infix expression, j for postfix expression. So the initial value of the j is 0 here. Okay. So what will happen? This is let it is our stack. Let it is our postfix expression. So in 0th index, what will happen? This ch will be stored. What is ch? A will be stored. Next j plus plus. Now j becomes 1. So this is nothing but our postfix expression. This is nothing but our stack. Okay. So this else if is executed. So this else won't execute. Now once again the control goes to the for loop. I plus plus. Now y becomes 1. So what is one character? Plus. So see here, next, plus not equal to null. Condition is true. Now ch contains plus. Okay. If plus double is equal to left parenthesis, false. Plus double is equal to right parenthesis, false. Next, plus is alpha bit digit, false. So this else block will be executed. So this else block will be executed if it is an operator. So here the code is very simple. While priority of ch is less than or equal to priority of the stack of top, double n top is not equal to -1. Okay. If these two conditions are true, then this body will be executed. If one of these condition is false or both the conditions are false, then this condition will be executed. So here what is the symbol? We have read plus. But here the stack doesn't contain any operator. Okay. What is the priority of the character? Plus priority. Okay. Priority of the ch. So control goes to the priority function. Now ch contains plus. So plus double is equal to left parenthesis false. Here plus double is equal to plus. Plus double is equal to plus. Condition is true. So it returns 1. So it contains 1. Next is less than or equal to priority of the stack of the top. What is stack of top? Top value is -1. So it doesn't contains. Here stack doesn't contains any value. As well as what is the top value here? What is the top value? No, the stack is empty. So top is -1. So -1 is not equal to -1. -1 is not equal to -1. Condition is false. So this push function will be executed. So push of ch. Here it is a symbol and the stack is not empty. So we have to push it onto the stack. So control goes to the push function. Now x contains plus, top plus plus. Now top is at 0th location. Stack of top is equal to x. So this plus will be stored here. This plus will be stored here. Okay. Next b. So what is b? Operand. Okay. So b not equal to null. Condition is true. ch contains b. B double is equal to left parenthesis false. B double is equal to right parenthesis false. Next b is an alpha bit. So what will happen? It is placed in postfix expression. Next j plus plus. Now j will becomes 1. Next character is star. Star not equal to null. Condition is true. Now ch contains star. Star double is equal to left parenthesis false. Star double is equal to right parenthesis false. Star is non-alpha bit, not digit. So this else block will be executed now. So while priority of the ch. So what is the operator we have needed? Star. So control goes to the priority function. What is the priority of the star? 2. So it will returns 2. Is less than or equal to priority of the stack of the top. What is top position? 0. What is stack of 0 plus? Next, priority of plus. So control goes to the priority function. What is the priority of the plus? 1. So it will returns 1. 2 less than or equal to 1. 2 less than or equal to 1. Condition is false. So this push function will be executed. So what is push function? Increment top value and store the character. What is the character? Star. So store star here. Next, plus. Plus is an operand. So place it in postfix expression. Okay. Next, plus. Next we have read plus here. Okay. Now let's check our logic. So plus not equal to null. Plus double is equal to left parenthesis. Plus double is equal to right parenthesis false. Plus is not alphabet, not digit. So this block will be executed. Okay. So while priority of the plus. So what is the priority of the plus? What is the priority of the plus? 1. So it will returns 1. Next, priority of the stack of the top. What is the priority of the stack symbol? Priority of stack of top. So what is top value? 1. Stack of 1 means star. So priority of 1. So control goes to the priority of star. So control goes to the priority function. Now ch contains star. What is the priority of the star? 2. 1 less than or equal to 2. Condition is true. And top not is equal to minus 1. 1 not is equal to minus 1. Condition is true. So both the conditions are true. So this will be executed. Okay. Postfix of j is equal to pop. Postfix of j is equal to pop. So control goes to the pop function. Here the code is return stack of top minus minus. Return stack of top minus minus. This is nothing but post decrement operator. So what is stack of top? 1. So 1 will be returned. Stack of top. Here what is the symbol? Star. So star will be returned and it will be assigned to postfix of j. So star will be stored here. Okay. So next what will happen? So it will be stored here. Next j plus plus. Now j will becomes 4. So once again condition will be evaluated. While priority of the ch. So what is the character? It is already over. 1. Next is less than or equal to priority of the stack of the top. Now top value is 0. So what is stack of 0? Plus. So priority of the plus. Control goes to the priority function. What is the plus priority? 1. So 1 will be returned. 1 less than or equal to 1. 1 less than or equal to 1 true. And 0 is not equal to minus 1 true. So postfix of j is equal to pop. So control goes to this function. Pop function. So return stack of top minus minus. What is stack of top? Stack of 0. Plus. So plus will be written and it will be stored in postfix expression. And it will be stored in postfix expression. Okay. J plus plus. Now j will becomes 5. Okay. J plus plus. Now j will becomes 5. So next what will happen? Once again control goes to the function. But what is top value now? Minus 1. Minus 1 is not equal to minus 1. Condition is false. So control comes out from the while loop. Push of ch. What is ch? Plus. So plus will be pushed onto the top of the stack. So till now we have seen about this operand as well as this priority functions. Now let's see left parenthesis and right parenthesis. In order to see left parenthesis and right parenthesis, let us take a simple expression a plus b. Okay. Now ch contains left parenthesis. This is one more example. If ch double is equal to left parenthesis, what is ch now? Left parenthesis. So push of ch. So left parenthesis is pushed onto the stack. Why? Because control goes to the push function. Top plus plus 0. Stack of top is equal to left parenthesis. So left parenthesis is stored here. Next a is an operand. So it will be stored in postfix expression. Next one is plus. Plus. So this block will be executed. So what is plus priority? 1. Next, what is the stack star post operator? Left parenthesis. What is left parenthesis priority? 0. So 1 is less than or equal to 0. So condition is false. So this push function will be executed. So plus will be pushed. Next b. Now let's see how right parenthesis will work. Let us assume that on bottom of this left parenthesis we have some other symbols like minus and star. Okay. So this is the symbol which we read at right parenthesis. So right parenthesis double is equal to left parenthesis. So condition is false. Right parenthesis double is equal to right parenthesis. Condition is true. So this block will be executed. While stack of top is not equal to left parenthesis. What is the top position? Plus. Plus is not equal to left parenthesis. Condition is true. And top is not equal to minus 1. This condition is also true. So postfix of j is equal to pop. So control goes to the pop function. And what is the stack topmost value plus? So plus is popped from the stack and placed in postfix expression. Now it will become top. Why? Because this is post increment operator. After returning, the decrementation will be done. Okay. Next, once again, the loop will be executed. Why stack of top is not equal to left parenthesis? But what is stack of top? Left parenthesis. So left parenthesis is not equal to left parenthesis. So condition is false. So control comes out of the while loop. So what is the statement here? Pop function. So control goes to the pop. So it will pop and places in. It will be popped. Okay. Return stack of top minus minus 1. It will pop, but should not place us in any postfix expression. And after that, why? Because that's why we use as pop here. Here we didn't use as any postfix of j here. Okay. Why? Because if it is right parenthesis, then we should not place left parenthesis in the postfix expression. So that's why here there is no left hand side variable like postfix of j is equal to. Okay. So return stack of top minus means stack of top will be returned. Okay. It will be returned, but here there is no left hand side variable. Okay. Next to top minus minus. So now top will be at this position. Okay. Top will be at this position. Okay. Now the entire infix expression is processed. Okay. Why? Because here the next character is, let us assume that the next character is null. Okay. So the control comes out from the for loop. What is the statement here? By top not equal to minus 1. What is top value? 1. So 1 is not equal to minus 1. Condition is true. So postfix of j is equal to pop. So it will be popped and stored in postfix expression. Next star will be popped and placed in postfix expression. So in this way we can convert infix expression to postfix expression. Now let's see about balancing symbols or delimiter matching. So by using this concept, by using this application, we can check whether the symbols such as parenthesis, so these are nothing but parenthesis symbols, braces, curly braces and brackets, these are nothing but brackets, are balanced or not. So in order to check whether our expression contains balancing symbols or not, we use this concept. Okay. So let me have an expression like this, left parenthesis and right parenthesis. So this is nothing but a balanced expression. Okay. So if you take this one, left parenthesis, left square bracket, right square bracket, right parenthesis. So this is also balanced expression. Why? Because which symbol we opened in the innermost left square bracket. So we have to close that symbol first, followed by this left parenthesis. So let us take this example. Left parenthesis, left square bracket, right parenthesis, left square bracket. This is not balanced expression. This is unbalanced expression. Why? Because here we opened left square bracket second. So first we have to close the left square bracket. Instead of that, we close right parenthesis followed by right square bracket. So we can say that this is unbalanced expression. So this is the major application. This is the major advantage here. We can check whether our expression contains balancing symbols or not. So here mainly our application, mainly our program contains, our input contains three types of symbols. So curly braces, square brackets and parenthesis. Okay. Here delimiter means symbols, delimiter matching, so symbol matching. Okay. So first let's see the algorithm, next followed by examples and program. So first step, read an expression from left to right. So the starting index is 0, whereas the last index is n minus 1. Okay, where n specifies the size of the string. Next second step, if the reading symbol is opening symbol means left symbol. So here what are the opening symbols? Left parenthesis, left square bracket, left curly braces. These are nothing but opening symbols. If the reading symbol is opening symbol, then push it onto the stack. Next step, if reading symbol is closing symbol, then do the following. Closing symbol means right symbol, right parenthesis, right square bracket, right curly braces. These are nothing but closing symbols. Okay. Let's see a bit in 3 here. If the stack is empty, then report as unbalanced expression. Otherwise, pop the stack. Okay. So whenever we read it a closing symbol, then what we have to do? We have to pop the stack. Suppose if the stack is empty, then we have to report failure, unbalanced expression. Suppose if the stack is not empty, then pop the stack. Let's see the next step. If the symbol popped is not the corresponding open symbol, then report as unbalanced expression. That means, let us assume that we read right parenthesis. Then the symbol popped should be left parenthesis only. Then only we can say that it is balanced expression. Suppose let us assume that we read a right parenthesis, whereas the symbol popped is left square bracket. So then we have to report as unbalanced expression. Okay. So what is the last step? After all the characters are processed, if the stack is not empty, then we can say that it is unbalanced expression. Otherwise it is balanced expression. So this is the algorithm here. So very simple here. Here we have only two steps. And the first step is if you read left parenthesis, then what we have to do. And the second step is if you read, the first step is if you read opening symbol, then what we have to do. And the second step is if you read closing symbol, then what we have to do. Okay. So if you read opening symbol such as left parenthesis, left square bracket and left curly brace, then we have to push the corresponding symbol onto the stack. And the second step is if you read closing symbol such as right parenthesis, right square bracket and right curly brace, then we have to check whether the stack is empty or not. If the stack is empty, then we can say that it is unbalanced expression. Suppose if the stack is not empty, then pop the stack. If the symbol popped is not the corresponding symbol, if the symbol popped is not the corresponding opening symbol, then we can say that it is unbalanced expression. Okay. So after processing the entire expression, if the stack is empty, then it is balanced expression. If the stack is not empty, then it is unbalanced expression. Now let's see some examples in order to demonstrate balancing symbols. Now let's see some examples. This is our expression, left parenthesis, right parenthesis and left square bracket. So we have to check whether this expression is balanced or not. So we know that it is unbalanced expression. Now let's check whether it is correct or not. So what is the first reading symbol? Left parenthesis. So left parenthesis. So left parenthesis. So if it is left parenthesis, then what we have to do? Left parenthesis is nothing but a opening symbol. So we have to perform push operation. So push operation. So push left parenthesis onto the top of the stack. So now stack contains left parenthesis. Here report means this is the last status, whether it is balanced or unbalanced. That status will be displayed while reading the last symbol of the stack. Okay. And what is the next symbol? Right parenthesis. Right parenthesis. Right parenthesis. So if it is right parenthesis means closing symbol. So if it is a closing symbol, then we have to perform pop operation. Pop operation. So pop left parenthesis from the stack. So now the stack is empty, because pop means deleting an element from the stack. So left parenthesis will be deleted from the stack. Okay. So now the stack is empty. Next, what is the next symbol? Left square bracket. So left bracket. The next symbol is left bracket. So left bracket is nothing but opening symbol. So if it is a opening symbol, then what we have to do? We have to perform push operation. We have to perform push operation. So push left parenthesis onto the top of the stack. Okay. So the entire expression is processed. Now if the stack is empty, then we can say that it is balanced expression. But here the stack contains left bracket. So what is the report here? So we can say that this is unbalanced expression. Unbalanced expression. Okay. Now let's check whether this expression is balanced or not. So reading symbol. Next, operation. So which operation we are performing? Stack. And what is the last one? A report. So what is the first symbol? Left square bracket. So if it left square bracket means opening symbol. So if it is opening symbol, then perform push operation. So now stack contains left square bracket. And the next one is left parenthesis. Left parenthesis means opening symbol. So we have to perform push operation. So now on top of the left parenthesis, left square bracket, left parenthesis will be pushed. Next one, right parenthesis. So right parenthesis means closing symbol. So if it is a closing symbol, then we have to perform pop operation. So which symbol we have to pop now? Topmost symbol. What is the topmost symbol? Left parenthesis. So left parenthesis is popped from the stack. So here the symbol popped is the corresponding opening symbol. Why? Because which symbol we have read it? Right parenthesis. And the symbol popped is left parenthesis. So they are matching. So there is no problem here. Okay. So now the stack contains only left square bracket. So what is the next symbol? Right square bracket. Okay. Right square bracket. That it is a closing symbol. So we have to perform pop operation. Okay. So what is pop operation? Deleting an element from this stack. So left square bracket will be deleted from this stack. Okay. So now what is left square bracket? It is nothing but the corresponding opening symbol only. Right square bracket, left square bracket. Both are matching. Okay. So now the stack is empty. The entire expression is processed and the stack is empty. So we can say that this is balanced expression. This is balanced expression. So in this way, with the help of some examples, we can demonstrate whether it is balanced expression or unbalanced expression. Now with the help of a C program, we will try to discuss in detail. So let's see a C program to implement balancing symbols. Now let's see a C program to implement balancing symbols or delimiter matching. So delimiter is nothing but a symbol. Okay. So here we can have some stdio.h and kana.h other files. Why? Because in this program we are using some printf functions and scanf functions. Next, here totally we are using 3 functions. The first function is push function. Push function is for pushing a opening symbol onto the top of the stack. So here the return type of the push function is void, and here we are pushing a symbol onto the top of the stack. So it accepts a character as the argument. And the next function is pop function. Pop function is for popping an element from the stack. So here by using pop function, we can pop a character from the stack. So the return type of the pop function is char, and the name of the function is pop, and it doesn't accept any parameters. And here in order to store the symbols, we require a stack. So char stack of 20. Next, the initial value of the top is -1. So if top is -1, then we can say that the stack is empty. We know that the execution of a program starts from main function. So char expression of 20. So this is for reading the expression of ch. In order to store each character of an expression, we are using ch variable. Printf enter expression gets of infix. So let the expression is like this: left parenthesis, right parenthesis, and left square bracket. So the index locations are 0, 1, 2. We know that every string ends with null character. So 3 is nothing but null character. So for I is equal to 0, expr of 0 not equal to null. What is expr of 0? Left parenthesis. So left parenthesis is not equal to null. Condition is true. Now ch contains left parenthesis. So let's check this condition. If ch double is equal to left parenthesis, or ch double is equal to left square bracket, or ch double is equal to left curly brace, it is a character. So we have to enclose within single quotation. So what is logical? Or if one of the condition is true, then the entire expression will become true. So left parenthesis double is equal to left parenthesis. This condition is true, whereas these two conditions are false. So whenever one condition is true, then the entire expression will become true. Why? Because we use logical OR operator. So push of ch. So what is ch here? Left parenthesis. So control goes to the push function. Now what is x? Left parenthesis. Top plus plus. So this is nothing but a stack. The initial value of the top is -1. So -1 plus 1 means 0. So now top will be at 0 index. Stack of top is equal to x. What is x? Left parenthesis. So left parenthesis will be stored in stack of 0. So once the program execution is over, then the control comes to the calling function. So what is the next statement? Else if. So if is executed, then else if ladder won't execute. Here if is executed, so else if ladder won't execute. So the control goes to I++. Now I becomes 1. So this is nothing but 1. Expr of 1 not equal to null. Expr of 1 means right parenthesis. So right parenthesis is not equal to null. Condition is true. So now ch contains right parenthesis. So first condition, right parenthesis double is equal to left parenthesis, right parenthesis double is equal to left square bracket, right parenthesis double is equal to left curly brace. So all the three conditions are false. So the entire expression is false. Next condition, right parenthesis double is equal to right parenthesis. Condition is true. So this body will be executed. If top double is equal to -1, but what is top value? 0. 0 double is equal to -1. Condition is false. So this condition will be executed. Next condition, else if ch is equal to pop. So this is nothing but pop function call. So control goes to the pop function call. So char pop return stack of top minus minus. Here this is nothing but post decrement operator. So what is post decrement operator? First stack of top value will be returned, and after that decrementation will be done. So stack of what is top value? 0. So stack of 0. So what is stack of 0? Left parenthesis. So left parenthesis will be returned and it will be assigned to ch. Now ch contains left parenthesis. Left parenthesis is not equal to left parenthesis. Left parenthesis is not equal to left parenthesis. So condition is false. So the control comes out from else if. Okay. So next control goes to I++. Okay. So what is the next symbol here? I++ means now y becomes 2. So expr of 2. So what is expr of 2? Here what will happen? A stack of top value will be written and after that top will be decremented. So top minus minus. So now top becomes 0 minus 1 means -1. So expr of 2 means left square bracket. So left square bracket is not equal to null. Condition is true. Now ch contains left square bracket. So left square bracket equal to left square bracket. Condition is true. So push off ch. So control goes to the push function top plus plus. Now top will become 0. Stack of top is equal to x. What is x here? Left square bracket. So now stack of 0 contains left square bracket. So this if is executed. So this else if won't execute. Okay. Next I++. I is 3. So expr of 3 means null. Null not equal to null. Condition is false. So the control comes out from the for loop. This is nothing but end of the for loop. Here after writing the code for right parenthesis, we have to write the code for right square bracket and right curly brace also. Okay. If it is right square bracket, then what is the code here? If it is right square bracket, then here we have to write as left square bracket. Okay. If it is right curly brace, then it is nothing but left curly brace. Okay. So likewise we have to write the code for space constraints. I have not written here. So likewise we have to, here we have 3 closing symbols. It may be either right curly brace or right square bracket or right parenthesis. So we have to write 3 else ifs here. Okay. So the control comes out from the for loop. If top double is equal to -1, but what is top value? 0. 0 double is equal to -1. Condition is false. So else block will be executed. What is else block? Unbalanced expression will be printed. Okay. So we can say that this is nothing but unbalanced expression. Now let's see a balanced expression and let's check whether our logic is correct or not. Okay. So let the expression is like this: left parenthesis, left square bracket, right square bracket and right parenthesis. Okay. So this is nothing but our infix expression. So 0, 1, 2, 3. So 4 means null. So for I is equal to 0, expr of 0 means left parenthesis. Left parenthesis is not equal to null. Condition is true. So now ch contains left parenthesis. Left parenthesis double is equal to left parenthesis. Condition is true. So push off ch. So control goes to the push function. Now x means left parenthesis. Top plus plus. The initial value of the top is -1. Now top becomes 0. So and store x in stack. So next control comes to the calling function. If is executed, so else if ladder won't execute. Else if ladder won't execute. Next I++. Now y becomes 1. So what is expr of 1? Left square bracket. Left square bracket is not equal to null. Condition is true. Now ch contains left square bracket. So this left square bracket equal to left square bracket. This condition is true. So push off ch. Push off ch. So control goes to the push function. Now x contains left square bracket. Okay. So top plus plus. Now top becomes 1. So what is stack of top now? Stack of top. Stack of 1 will become x. X means this left square bracket. Okay. So next control comes to the calling function. If is executed, so this else if won't execute. I++. Now y becomes 2. expr of 2 means right square bracket. So right square bracket is not equal to null. Condition is true. Now CH contains right square bracket. So these three conditions will become false. Now what is the symbol here? Right square bracket. Here left square bracket. Okay. So right square bracket double is equal to right square bracket. Condition is true. If top double is equal to -1, but what is top value? 1. 1 double is equal to -1. False. So this condition will be executed. Else if CH is equal to pop, this is nothing but pop function call. So control goes to the pop function call. Return stack of top. What is top value? 1. So what is stack of 1? Left square bracket. So left square bracket will be returned. Left square bracket will be returned and it will be assigned to CH. Now CH contains left square bracket. Next, this is post decrement. So after that, decrementation will be done. The previous value of the top is 1. So now top will become 0. So what is CH now? Left square bracket. Left square bracket not equal to left square bracket. So condition is false. So I plus plus. Now I becomes 3. EXPR of 3 means right parenthesis. Right parenthesis not equal to null. Condition is true. Now CH contains right parenthesis. This condition is false. Now what is CH now? Right parenthesis. If it is right parenthesis, then we have to write the corresponding opening symbol. Okay. So right parenthesis double is equal to right parenthesis. Condition is true. So next, right, top double is equal to -1. What is top? 0. 0 double is equal to -1. False. Next, else if CH is equal to pop. So control goes to the pop function. Return stack of top minus minus. This is post decrement. So first stack of top will be returned. What is top value? 0. What is stack of 0? Left parenthesis. So left parenthesis will be written and it will be assigned to CH. Now CH contains left parenthesis. And after that top will be decremented. The previous value of the top is 0. So now top will become 0 minus 1 minus 1. Left parenthesis equal to left parenthesis. Left parenthesis is equals to the left parenthesis. Left parenthesis is not equals to the left parenthesis. Left parenthesis is not equals to the left parenthesis. So condition is false. Okay. So the control comes. So the next. So I plus plus. So what is, because this is executed. Okay. So now the if else is executed. So the control goes to I plus plus. Okay. Now what is I value? 4. EXPR of 4 means null. Null not equal to null. False. So the control comes out from the for loop. So what is top value now? -1. -1 double is equal to -1. So balanced expression will be printed. So in this way we can implement balancing symbols with the help of stacks. Now let's see about queues. Queue is a linear data structure. That means in a queue the items are arranged in linear fashion. We can define a queue as a collection of items in which we can insert the item from the end of the queue and we can delete the item from the beginning of the queue. We can represent a queue in a diagrammatic format like this. So this is nothing but a queue. So let the size of the queue is 5. So we can have 5 elements from 0 to 4. So let it is printed. Let it be. So it is the queue here. So we can perform insertion operation by using end of the queue. So this end of the queue is known as rare end, and we can perform deletion operation from beginning of the queue. So this beginning end is known as front end. So we have two types of ends, front end and rare end. Okay, we can perform deletion operation from front end, that is nothing but beginning of the queue, whereas we can perform insertion operation from end of the queue, that is nothing but rare end. Okay, so this is about the definition of a queue. We can implement queues in two ways. The first approach is implementation of queues using arrays, and the second approach is implementation of queues using linked list. So in this video we will discuss about how we can implement queues with the help of arrays. In the next video we will see how we can implement queues with the help of the linked list. Okay. Mainly we can perform 3 operations on the queue. The first operation is enqueue operation, and the second operation is dequeue operation, and the third one is display operation. So NQ operation, DQ operation and display operation. NQ means inserting an element into the stack. We know that we can perform insertion operation into the queue from variant. Whereas DQ means deleting an element from the queue. We know that we can perform deletion operation from the front end, that is nothing but beginning of the queue. And the next one is display. So display means displaying the elements of the queue from front to variant. Queue works on the principle of FIFO. FIFO stands for first in first out. First in first out means the element which is inserted first into the queue will be deleted first from the queue. So the element which is inserted first into the queue will be deleted first from the queue. Here in stands for insertion, out stands for deletion. So let we have a queue like this. Let the size of the queue is 3, so that we can enter totally 3 elements into the queue starting from 0 to 2. So let the first element which is inserted is 10 and the second element which is inserted is 20. Let the third element which is inserted is 30. So while performing the deletion operation, that is nothing but DQ operation, the element which is inserted first into the queue will be deleted first. So out of 10, 20 and 30, so 10 is the element which is inserted first. So first to 10 will be deleted. Okay. Next, out of 20 and 30, which element is inserted first? 20. So now 20 will be deleted from the queue. So likewise, queue operations will be performed. NQ and DQ. So NQ means inserting an item into the queue. DQ means deleting an item from the queue. Let's see some examples for the queue. The first example, a line of people waiting at a bank. So what will happen if there are 10 people in a queue at a bank? Then the first person in the queue will be served first. Likewise, a line of people waiting at a movie ticket counter. Okay. So the first person in the queue will get the ticket first. Okay. Next one, processing of jobs in a operating system. So in a computer we can execute several jobs simultaneously. So then how the processor will execute the jobs? So that depends upon the jobs which come first. Okay. Suppose if P1 comes first, if program P1 comes first, then P1 program will be executed first. Like we have 3 jobs like this, P1, P2, P3. So first P1 comes first, next P2 comes, next P3 comes. So which job first comes? P1. So first P1 will be executed. Next, out of P2 and P3, which job comes first? P2. So next P2 will be executed. So these are some various examples of the queue. So let us implement queues with the help of arrays. Here we have to declare the size of the queue. So for that purpose, let us define a macro. So hash define space. Let name of the macro constant is size 5. So that here the maximum size of the queue is 5. Okay. Next we need to declare an array. So int. Let the name of the array is queue. So int queue of. So what is the size of the queue? Size. Here we declared this one as macro constant. Why? Because the major advantage of this macro is once we declare a constant with the help of macro, then it is not possible to change its value throughout the program. Okay. So throughout the program size value should be 5 only. So that's why we declared this size as a macro constant. Okay. So in this way we can define the macro as well as we can declare the size of the array. So here what is the size of the array? 5. We know that the index of an array starts from 0 and continues up to size minus 1. So now index of the array starts from 0 and continues up to 5 minus 1, that is nothing but 4. Let us perform the first operation. So the first operation is NQ operation. Okay. So let us perform NQ operation. So already we discussed about what is NQ. So NQ means inserting an element into the queue. Here, so this is a queue here. This is a queue. So what is the size of the queue? The size of the queue here is, let the size of the queue is 5, so that we can store totally 5 elements from 0 to 4. Okay. Initially we have to take two variables, front and rear. So the initial value of the front is minus 1, as well as the initial value of the rear is minus 1. So if front is minus 1 and rear is minus 1, then we can say that the queue is empty. We know that we can perform NQ operation from the rear yet. So in order to perform the NQ operation, so first we have to increment rear value. So minus 1 plus 1 means 0. So now rear will be at 0 location. Now read an element and insert the corresponding element into the queue. Here the element is 10, so insert the element into the queue. Here rear always points to the end of the queue and front points to the beginning of the queue. So after inserting an element into the queue, so rear is at 0th location, so front is also at 0 location, because front always points to the beginning of the queue. Here what is the starting index? 0. Let us perform NQ operation one more time. So in order to perform the NQ operation, we have to increment rear value. So the previous value of the rear is 0. So 0 plus 1 means 1. So now rear will be at 1 location. Front is at 0 location. Okay. So read an element and insert the element into the queue. So that the element is 20. So insert the element into the queue 20. Okay. So this is nothing but rear end of the queue. So this is nothing but front end, beginning of the queue. Let us perform NQ operation one more time. So what we have to do? We have to increment the rear value. So the previous value of the rear is 1. So 1 plus 1 means 2. So now rear points to 2. Read an element and insert the element into the queue. Let us perform NQ operation one more time. Here the size of the queue is 5. So we can enter 5 elements into the queue, starting from 0th index to 4th index. Okay. So let us perform NQ operation one more time. So now rear becomes 3. Read an element, let the element is 40. So insert the element into the queue. Next let us perform NQ operation one more time. So increment rear value. So now rear is at 4th index. Read an element and insert the element into the queue. Okay. Now let us perform one more NQ operation, but the queue is full. So in order to perform the NQ operation, first we have to check whether the queue is full or not. If the queue is full, then it is not possible to perform the NQ operation. If the queue is not full, then only we can perform the NQ operation. So while performing the NQ operation, there are two cases. So the first case is when the queue is full, and the second case is when the queue is not full. Okay. So when the queue is full, here what is rear value? Rear value is 4. What is size value? 5. So if rear double is equal to size minus 1, what is size value? 5. So if rear double is equal to size minus 1, then we can say that the queue is full. Else, so what we are doing here, we have to read an element and increment rear value and store the corresponding value in the queue. So let us write the code for NQ here. So before inserting the item, we have to check whether the queue is full or not. So if rear double is equal to size minus 1, so here size specifies the maximum size of the array. Here what is the size of the queue? 5. Okay. Then we can say that printf queue is full. So this condition is also known as overflow. So what is overflow? When the queue is full, if we try to insert an element, then overflow will occur. Okay. Else, so what we have to do? First we have to increment the rear value. So rear plus plus. Next read the element. So printf enter the element. Printf enter an item to be inserted into the queue. Next scanf %d comma ampersand. Let the name of the variable is item. Here what is the name of the queue? Let name of the queue is queue So Q of rear is equal to item. Q of rear is equal to item. Next, we have one more statement. What is that statement? If front double is equal to -1. So initially the values of front and rear are -1. If front double is equal to -1, then front is equal to 0. So while inserting the first element, we have to place front at 0th location. Okay. So in this way we can perform the NQ operation. So let us check whether our logic is correct or not. So the initial values of the front and rear are -1. Okay. So this is nothing but our Q. So if rear double is equal to size -1, so what is rear value? -1. -1 double is equal to, what is the size here? 5. 5 minus 1 means 4. So -1 double is equal to 4. Condition is false. That means Q is not full. So else block will be executed. So rear plus plus. So what is rear value now? 0. So rear will be at 0 index now. So let the item is 10. So insert item into Q of what is there? 0. So Q of 0 is equal to 10. Next, if front double is equal to -1. So what is the initial value of front? -1. Then front is equal to 0. So now front will be at 0th location. Next, let us perform NQ operation one more time. If rear double is equal to size -1, what is rear value? 0. 0 double is equal to 4. Condition is false. So else block will be executed. Rear plus plus. So now rear will become 1. So now rear will be at 1 index. Okay. Printf enter the item. Let the item is 20. So insert item in Q of rear. Q of 1. So insert 20 here. Next, if front double is equal to -1, what is front? 0. 0 double is equal to -1. Condition is false. So this condition is false only by inserting the first element. So otherwise this body won't execute. So let us perform NQ operation one more time. Okay. If rear double is equal to size -1, so what is rear value? 1. So 1 double is equal to 4. Condition is false. So H block will be executed. So in 2th location what will happen? 30 will be inserted. So likewise NQ operation will be done. Now let's see how we can perform DEque operation. So we know what is DEque operation. So DEque operation means deleting an element from the queue. Deleting an element from the queue. We know that we can perform deletion operation from beginning of the queue. That is nothing but front of the queue. So let we have a queue like this. So 0, 1. Let the size of the queue is 5. So 0, 1, 2, 3, 4. So 10, 20, 30, 40, 50. So we know that front always points to the beginning of the queue. So front is at 0th index. And rear always points to the end of the queue. So rear is at index 4. Now we are performing deleting operation, DEque operation from the queue. We know that we can perform DEque operation from beginning of the queue. So deleted element from the queue is, so front is at 0th location. So deleted element is 10. So after that this element is deleted from the queue. So after that front should point to the location 1. So front plus plus. Okay, this is the logic here. Now perform DEque operation one more time. So deleted element is 20 because this is the front of the queue now. So 20 will be deleted. Then after that front plus plus. So 1 plus 1 means 2. So front will be at 2th location. Next, let us perform DEque operation one more time. So what is the beginning of the queue now? Front 30. So 30 will be deleted. Now front should point to the 3 because this second index will be decremented. So front points to the 3. Next, let us perform DEque operation one more time. So 40 will be deleted from the queue. Next, increment front value. Now front and rear are at 4th index. Okay. So after deleting this value, if front and rear double is if front equal to rear, if front and rear are equal, then after deleting the corresponding element, we have to place front and rear at -1 because what are the initial values of front and rear? -1. Okay. if the queue contains only one element, then if you perform the deletion operation, then the queue will becomes empty. So we need to place front and rear at -1. So let we have an element like this. Let the second index contains some 70. So now what will happen? The queue contains only one element. So front and rear will be at the second index only. So in order to delete the element, what is the logic here? We have to delete the value at the front, that is nothing but 70 will be deleted. But after deleting that value, the corresponding queue is empty. So what we have to do? We have to place front and rear at -1. Because in this logic, if we increment front, then what will happen? Front will be placed at 3 location, but 3 doesn't contain any value. So here we have 3 cases. Here the logic is we can perform DEque operation. We can perform deletion operation from the queue only when the queue is empty. So if the queue is empty, then only we can perform the deletion operation. If the queue is not empty, then it is not possible to perform the deletion operation. So here we have 3 cases. The first case is when the queue is empty. The second case is when the queue contains only one element. The third case is when the queue contains more than one element. So what is the first case? When the queue is empty. So when the queue is empty, if front is -1 as well as rear is -1, then we can say that the queue is empty. And what is the second case? If the queue contains only one element. So when the queue contains only one element, if front and rear are same, if front double is equal to rear, then we can say that the queue contains only one element. So if the queue contains only one element, then what we have to do? After deleting that element, we need to place front and rear at -1. Why? Because the queue contains only one element. So after deleting that element, the queue obviously will become empty. Okay. Else, that means if the queue contains more than one element. So if the queue contains more than one element, then what we have to do? We need to delete the corresponding value at the front and then increment front value. So this is the logic which we have to write. So let's write the logic. So what is the first case? When the queue is empty. So when the queue is empty, if front is -1 as well as, that means we have to use double end. If both these conditions are true, then we can say that the queue is empty. So print of queue is empty. So this can also be known as underflow. So underflow means deleting an item from the queue when the queue is empty. Deleting an item from the queue when the queue is empty. And the second condition is if the queue contains only one element. So when the queue contains only one element, if front and rear are equal. So else if front double is equal to rear, then what we have to do? We have to delete the element. So print of deleted item is percentage d comma q of front. So after deleting the item, we need to place front and rear at -1. So front is equal to -1, rear is equal to -1. Else, so when this else block will be executed, if the queue contains more than one element. So if the queue contains more than one element, then also delete the item. So deleted item is percentage d comma. So we can perform deletion operation from front end. So q of front, and then we need to increment front value. So in this way we can perform DEque operation from DEque. Now let's check whether our logic is correct or not. So that we have 3 elements. So 0, 1, 2. So front points to the 0th location, rear points to the second location. So 10, 20, 30. So that the size of the queue is 3. So if the size of the queue is 3, then we can insert only 3 elements into the queue. So let us perform the DEque operation. Front double is equal to -1, rear double is equal to -1. So 0 double is equal to -1, 2 double is equal to -1. So both the conditions are false. So second condition will be checked. Front double is equal to rear, 0 double is equal to 2. Condition is false. So this else block will be executed. So deleted item is percentage d comma q of front. So what is q of front? 10. So 10 will be deleted. And then front plus plus. So front will be one location, one index. So let us perform DEque operation one more time. So friend double is equal to minus 1. 1 double is equal to minus 1. 2 double is equal to minus 1. False. So second condition will be checked. 1 double is equal to 2. False. So else block will be executed. So deleted item is percentage d comma q of friend. So what is q of 120? So 20 will be deleted. Friend plus plus. So now friend points to rear location. So now friend and rear are at second index. Let us perform DEque operation one more time. Okay. If friend double is equal to minus 1, rear double is equal to minus 1. So 2 double is equal to minus 1, 2 double is equal to minus 1. So both the conditions are false. So this block will be this condition will be evaluated. So friend double is equal to rear. 2 double is equal to 2. Condition is true. So deleted item is, so what is the deleted item? 30 will be deleted. And then friend and rear will become minus 1. So friend is equal to minus 1, rear is equal to minus 1. So let us perform DEque operation one more time. So friend double is equal to minus 1, rear double is equal to minus 1. Both the conditions are true. So Q is empty will be printed on the monitor. So in this way we can perform the DEque operation. Now let us perform the last operation, that is display operation. So display means simply we have to display the values from friend to rear. So here before performing the display operation we have to check whether the Q is empty or not. So we know when the Q is empty. If friend is minus 1 as well as rear is minus 1, then we can say that the Q is empty. So else simply display the values from friend to rear. So for I is equal to friend, I less than or equal to rear, I plus plus printf percentage d slash d comma q of I. So let we have three values here. So friend is at 0th position, friend points to the beginning of the queue, rear points to the end of the queue. So friend double is equal to minus 1, rear double is equal to minus 1. 0 double is equal to minus 1 false, 2 double is equal to minus 1 false. So this else block will be executed. So I is equal to friend. So what is friend? 0. Next 0 is less than or equal to rear. So 0 is less than or equal to 2. Condition is true. So Q of 0 will be printed. So what is Q of 0? 10 will be printed. Next I plus plus. I becomes 1. So 1 less than or equal to 2. Condition is true. Q of 1. 20 will be printed. I plus plus. I will become 2. 2 less than or equal to 2. Condition is true. 30 will be printed. I becomes 3. 3 is less than or equal to 2. Condition is false. So the control comes out from the for loop. So in this way we can implement queues with the help of arrays. Now let's see about queues using linked list. We know what is a queue. Queue is a linear data structure in which we can perform insertion operation from end of the queue, that is nothing but rear end, and we can perform deletion operation from the beginning of the queue, that is nothing but front end. We can implement queues with the help of arrays as well as linked list. The major disadvantage of queues using arrays is if we use arrays for implementation of queues, then we must know in advance regarding the size of the array. So how many elements we need to be stored in the array. Like we declared the size of the array as 5, but during runtime we want to increase the size of the array or we want to decrease the size of the array. Then it is not possible with the help of the arrays. We can overcome that problem with the help of the linked list. Okay, we know here in order to implement the queue we are using a single linked list. We know what is a single linked list. It is a collection of nodes where each node contains some data field and next field. Data field contains some value, next field contains address of the next node, the last node next field contains null value. Okay, initially let's see the declaration for a node. So struct name of the node is node. Here the node contains two fields. The first field is data field. Let the data field is of type some integer, and the second field is next field. So struct the node star next, and we uses some structure variables star new, star front, star rear, and star temp. So these are nothing but some structure variables. New for allocating the memory. Front always points to the beginning of the queue. Rear always points to the end of the queue. 10 for traversing from one node to the another node. On Q mainly we can perform three operations. First operation is NQ operation. Second one is DQ operation. Third operation is display operation. So mainly we can perform three operations. So NQ means inserting an element into the queue. DQ means deleting an element from the queue. Display means displaying the elements of the queue from front to the rear end. Let us perform NQ operation first. So what is NQ? Inserting an element into the queue. So NQ means inserting an element into the queue. First let's see the logic for NQ. First we have to allocate memory for a node. For allocation of the memory we are using U here. So this node contains two fields. First field data field, second field address field. Let address of the node is 1000. So read a value and store value in data field. Next store null in next field. So here first we have to check whether the queue is empty or not. We can say that a queue is empty if friend double is equal to null. Okay, friend, rear, new, temp all are defined as some global structure variables. So the default initial values are null only. So the initial value of the friend is null. So if friend is null, then we can say that the queue is empty. So we have to place friend and rear at new location. So place friend and rear at new location. Okay. So then after that here we have to insert an element into the queue. In order to insert an element into the queue, we use rear end here. So let us perform the NQ operation one more time. So first allocate the memory for the node. So name of the node is new. Let address of the node is 2000. It contains two fields. So store value in data field. Next store null in next field. Okay. Here in order to perform the insertion operation we are using rear end. We are using which end? We are using rear end here. So we have to establish a connection from this node to this node. So store 2000 here. So that a link will be formed like this. Next, place rear at the next node. Okay, because rear always points to the end of the queue. So after inserting the second element, so this node will becomes the end of the queue. So we have to place rear at new location. Okay. So likewise perform NQ operation one more time. So allocate memory for the node. So name of the node is new. Name of the node is new. Let address of the node is 3000. So what we have to do? Store value here, store null here. So store address of the next node, that is nothing but 3000 here in next field. Then a link will be formed like this. Then after that we have to place rear here. So this is the logic for NQ operation. So let us write the code here. Okay. So first what we have to do? We have to allocate memory for the node. So new is equal to struct node star malloc of size of struct node. Okay, malloc of size of struct node. Okay, next read a value. So first allocate memory for the node. So what we have now? So first memory will be allocated for new. That address is 1000. So it has two fields. Okay. So next read a value. So printf enter a value. Printf enter an item. Enter an item. Next scanf %d comma ampersand item. So next we have to store item in new data field. So new arrow data is equal to item. New arrow data is equal to item. Let the item is 10. So 10 will be stored at new data field. Next we have to store null in new next field. So new arrow next is equal to null. So store null here. Next we have to check whether the queue is empty or not. So when the queue is empty, we can write the condition as if friend double is equal to null or rear double is equal to null, or if both the conditions are true. So if friend double is equal to null, so initial value of the friend is null. And we can write one more condition here, and rear double is equal to null. If these two conditions are true, then we can say that the queue is empty. So what we have to do? we have to place front and rear at new location. So front is equal to new. So what is new? 1000. Next rear is equal to new. So front and rear are placed at 1000 memory location. So let us perform NQ operation one more time. So what will happen? So memory will be allocated for new. So let address of the node is 2000. So here we have two fields. Next read the item. Let the item is 20. So this will be arranged and new will be at 2000. So let the item is 20. 20 will be stored here. Stored null here. Okay. Next check this condition. But what is front here? 1000. What is null? 1000. So both the what is rear? 1000. So both the conditions are false. So we can say that the queue is not empty. So what we have to do? Now we have to insert an item into the queue from rear end. So rear arrow next is equal to new. So what is new? 2000. So if we store 2000 in rear next, then a link will be formed like this. Next to move rear one position to the right. So what is the first statement? Rear arrow next is equal to new. Next statement, rear is equal to new. So in this way we can perform insertion operation in the queue. Now let us perform DEque operation. Okay. So DEque means deleting an element from the queue. We know that we can perform deletion operation from front end. So let our queue contains 3 elements. So let the first node address is 1000. Let the second node address is 2000. Let the third node address is 3000. Here each node contains 2 fields. So 10, 2000. If we store 2000 here, then a link will be formed from first node to the second node. Next to 20, 3000. So 20 means data field, 3000 means next field. Next to 30, null. So next, front points to the beginning of the queue. So front is at 1000 memory location. Rear points to the end of the queue. So rear is at 3000 memory location. So here the logic is very simple here. So if we perform DEque operation, then we have to delete 10 from the queue, and after that we need to place front at 2000 memory location. Okay. So before performing the DEque operation, we have to check whether the queue is empty or not. Why? Because if the queue is empty, then it is not possible to perform the deletion operation. So when we can say that the queue is empty, if front is null and rear is null, then we can say that the queue is empty. Okay. So if front double is equal to null, and rear double is equal to null, then we can say that printf queue is empty, or we can also known as underflow. Underflow means trying to delete an element from the queue when the queue is empty. Okay. Else, so what we have to do? We need to place a variable called temp at front. So delete the topmost element from the queue. That is nothing but delete 10 from the queue. So after deleting this node has to become the first node. So we have to move front one position to the right. Then after that, in order to break this connection, place null here and destroy the memory for the temp. Okay. So what we have to do now? First, display the value. So printf deleted element is %d comma front arrow data. So what is front arrow data? 1000 data means 10. So 10 will be deleted from the queue. So next, after deleting this node has to become the first node. So we have to place front at 2000. So front means 1000. So 1000 next means 2000. So here the statement is front is equal to front arrow next. So now front is at 2000 location. So in order to break this connection, we have to place null here. So temp arrow next is equal to null. Next, there is no need of this memory now. So free of temp. So that the temp memory is useful for storing some other variable. So in this way we can perform a DEque operation with the help of the front end. Now let us perform display operation. Now let's see about display operation. Here we have to display the elements of the queue. So we have to display the elements as from front to rear we have to display the elements. So 10 arrow, 20 arrow, 30 arrow. So this arrow specifies there is a link from one node to the another node. So here the logic is very simple. So if the queue is empty, then it is not possible to perform the display operation. So when the queue is empty, if front value is null as well as rear value is null, then we can say that the queue is empty, so that it is not possible to perform the display operation. Otherwise, place a structure variable called temp at front end. Here we are using temp for traversing from one node to the another node. Check whether temp is not equal to null or not. If it is not equal to null, then display the data and move temp one position to its right. So we have to repeat the loop as long as temp is not equal to null. So whenever temp becomes null, then we can say that displaying of queue's data is over. Okay. So first write the condition for whether the queue is empty or not. So if front double is equal to null and rear double is equal to null, then we can say that the queue is empty. So printf queue is empty, or we can write it as underflow. So what is underflow? So underflow occurs when we try to delete an element from the queue when the queue is empty. So underflow means queue is empty. So else, so place temp at front. So temp is equal to front. Next we have to repeat the loop as long as temp is not equal to null. So while temp is not equal to null, display temp data. So printf %d. So if you want, use some arrow symbol, temp arrow data. So after displaying the data, move temp one position to the right. So temp is equal to temp arrow next. Next, to close the while loop, close the else loop. Now let's check whether our logic is correct or not. So what is front? Null. What is front? 1000. What is rear? 3000. So 1000 double is equal to null, 3000 double is equal to null. So condition is false. So this else block will be executed. So temp is equal to front. So temp is placed at 1000 location. So while 1000 is not equal to null, condition is true. So 1000 data will be printed. So temp, after that this arrow will be printed. Temp is equal to temp arrow next. So temp means 1000. 1000 next means 2000. So temp will be placed at 2000 now. Okay. Once again condition will be checked. While temp 2000 is not equal to null, condition is true. So temp data will be printed. So what is temp data? 20 arrow will be printed. Next, temp is equal to temp arrow next. So 2000 next means 3000. So temp will be placed at 3000 now. So while temp not equal to null, 3000 is not equal to null, condition is true. So what is temp data? 30 arrow. 30 arrow will be printed. Temp is equal to temp arrow next. 3000 next means null. So now temp means null. So null not equal to null, condition is false. So the control comes out from while loop, else loop. So in this way we can implement queues using linked list. Now let's see about circular queue. Circular queue is mainly useful in order to overcome the drawbacks of normal queue or linear queue. Let's see the drawback of normal queue or linear queue. Let us assume that queue contains 5 elements. So we have a queue like this. Let us assume that queue is implemented with the help of the arrays. So let the size of the queue is 5. So totally we can have 5 elements from 0 to 4. Let the first element is 10, second element is 20, third element is 30, fourth element is 40, fifth element is 50. We know that front points to the beginning index. So front points to the 0 and rear points to the last index, that is nothing but 4. Let's perform 2 DEque operations. We know that we can perform DEque operations from the front end. So if we perform DEque operation, then 10 will be deleted from the queue, and after that front will be at first position. Let us perform DEque operation one more time. So 20 will be deleted from the queue and front points to the second position. Now here the drawback is if rear reaches to the end of the queue, then it is not possible to insert elements into the queue even though there is a space at beginning of the array. So in this queue we have two empty locations, okay. So 0th location as well as 1 location. These two locations doesn't contains any value, but it is not possible to insert the values at 0 and 1. Why? Because from 4th location it is not possible to move to the 0 location in linear queue. So that is the drawback of linear queue or normal queue. So what is the drawback of linear queue or normal queue? If rare reaches to the end of the queue, then it is not possible to insert values in the queue even though there is a space at beginning of the queue, okay. So in order to overcome the drawbacks of linear queue, we use a circular queue. Let's see the definition of a circular queue. A circular queue is a linear data structure in which all the items are treated as circular, in which the first location follows the last location. So generally a circular queue is represented in a diagrammatic format like this. So this is nothing but a circular queue. Circular queue. So let size of the queue is 5. So we can have 5 elements from 0 to 4. A circular queue is a linear data structure in which all these items are treated as circular, such that the first location, that is nothing but 0th index, follows the last location, that is nothing but size minus 1, okay. So that is the advantage of the circular queue. If you take linear queue, then it is not possible to move from the last index to beginning index, whereas in circular queue we can go from the last index to beginning index. So let's see how that can be happened. In a normal queue, after performing enqueue operation, that is nothing but insertion operation, and for performing deque operations, we write a statement as for insertion rare plus plus, for deletion friend plus plus, okay. After inserting an element into the queue, we have to increment rare value. Likewise, if we want to perform deletion operation, then we have to decrement the friend value. Whereas here we can write the statement as rare is equal to rare plus 1 modulo size. Rare plus 1 modulo size. Likewise for the friend also, in order to move from one location to another location, we write as friend is equal to friend plus 1 modulo size. Here what is the size of the circular queue? 5. So that we can have 5 elements from 0th index to the 4th index, okay. So let's see whether our logic is correct or not. So let us assume that we are at 0th location. So after that we need to go to 1 location. So we can write as 0 plus 1. 0 plus 1 means 1. So 1 modulo, what is the size here? 5. So what is 1 modulo 5? So 5 1, 5 zeros are 0. So 1 minus 0 means 1. So modulo will give remainder. So likewise, if you want to go from 1 to 2, then 1 plus 1 means 2. 2 modulo 5 means 2. 2 modulo 5 means 2. So 5 by 2. So 5 zeros are 0. So 2 minus 0 means 2. Next, if you want to go from 4 to 0, then we can write as 4 plus 1. So 4 plus 1 means 5. So 5 modulo 5. 5 modulo 5. So 5 ones are 5. So 5 minus 5, 0. So we can go to 0th location from 4th location also. So this is the modification which we have to do. So in place of rare increment, we have to write as rare is equal to rare plus 1 modulo max. Here we have to enclose rare plus 1 and friend plus 1 within parenthesis. Why? Because parenthesis has higher priority than modulo operator. If you don't use parenthesis, then what will happen is rare plus 1 modulo size. Then what will happen is between plus and modulo has higher priority. So first 1 modulo size will be done, and after that the result will be added to the rare. But actually what we have to do, first we have to perform rare plus 1, okay. So that's why we have to enclose rare plus 1 in parenthesis, okay. On circular queue also we can perform 3 operations just like normal queue. So first operation is enqueue, second operation is DEque, third operation is display operation. So we know what is NQ. NQ means inserting an item into the queue, DEque means deleting an item from the queue, and display means displaying the elements of the queue. So let us perform the first operation. The first operation is NQ. So what is NQ? NQ means inserting element into the queue. Just like normal queue, here also we can perform insertion operation from rear end, deletion operation from front end. Insertion from rear end, deletion from front end. So let's see the first operation. So what is the first operation? So the first operation is NQ. NQ operation. So what is NQ? NQ means inserting an item into the queue. Okay. So let us draw the circular queue first. So let the size of the circular queue is 5, so that we can have 5 elements from 0 to 4. Why? Because here we are using arrays. The index of an array starts from 0 and continues up to size minus 1. So and continues up to 5 minus 1. So 5 minus 1 is nothing but 4. So let's see the logic here. So what we have to do? So here we need to take two variables, front and rear. The initial values of front and rear are minus 1. So front is equal to minus 1, rear is equal to minus 1. So if front value is minus 1 and rear value is minus 1, then we can say that the circular queue is empty. And we have to take an integer array. So int, so let name of the array is CQ. So CQ of, let the maximum size of the array is 10. So that we can maximum enter 10 elements into the circular queue. Okay. Next, before that, it is better to declare size as a macro. So hash define size 5. So here the size of the queue is int CQ of size. So here declare size as a macro. Why? Because the advantage of the macro is, if you declare a constant with the help of the macro, then it is not possible to change its value throughout the program. So throughout the program, size value should be 5 only. So CQ is an integer array, and what is the size of the CQ? Size variable. So what is size here? 5. Okay. So int CQ of size. So these are nothing but some variables which we declare in the program. Okay. Let us perform NQ operation now. So what are the initial values of the front and rear? The initial values of the front and rear are minus 1. So if front is minus 1 as well as rear is minus 1, then we can say that the circular queue is empty. So let us perform the NQ operation here. We know that we can perform NQ operation from rear end, but here what is the starting index here? 0. Whereas what is the initial value of the rear? Minus 1. So first we have to increment rear value. So now rear will be at 0th location. Rear will be at 0th location. Let us read an element. Let the element is 10 and insert the element in the corresponding circular queue. So let the element is 10. So insert 10 at 0th location. So we can write the statements as printf enter element, scanf %d comma ampersand element, and what is the name of the queue? CQ. CQ of, we are performing insertion operation from rear end. So CQ of rear is equal to, what is the element here? ELE. Okay. So first we need to increment rear value. And next, here we are using a variable called front. Front always points to the beginning of the circular queue. So after inserting an element into the queue, then front will be at 0th location. So we have to place front at 0th location. Okay. Next, let us perform NQ operation one more time. So what we have to do? We have to increment rear value. So how to increment rear value? What is the formula here? Rear is equal to rear plus 1 modulo size. What is the value of rear? 0. So 0 plus 1 means 1. 1 modulo 5 means 5. So now rear will be at 1. Whereas front will be at 0 only. So now rear will be at 1. So read an element. Let the element is 20 and insert the element at the corresponding rear position. Let us perform NQ operation one more time. Let the element is 30. So what we have to do? First we have to increment the rear value. What is rear? 1. So 1 plus 1 means 2. So 2 modulo 5 means 2. So rear will be at second position. So insert the value 30. So let us perform NQ operation. Increment the rear value. Rear is at 3, 40. Next, let us perform NQ operation one more time. So rear is at 4th location. So insert the element. Okay. Now the circular queue is full. So when we can say that the circular queue is full? If front value is 0 and rear value is 4. If front value is 0 as well as rear value is 4, then we can say that the circular queue is full. So both these conditions must be true. Suppose if front value is at second location, then that means these two are empty locations. Okay. So we can insert some elements at 0th location as well as one index location also. So we can say that a circular queue is full when front is at 0th location and rear is at 4th location. Here what is 4? 4 means size minus 1. So if those two conditions are true, then we can say that the circular queue is full. Okay. Now let us perform two DEque operations. We know what is DEque operation. So DEque means deleting an element from the queue. DEque means deleting an element from the queue. So we can perform DEque operation from the front end. So let us perform one DEque operation. So first to 10 will be deleted from the queue, and after that front is equal to front plus 1 modulo size. So 0 plus 1, 0 plus 1, 1. Okay. So what will happen first? First it will be deleted. Okay. So what is the value here? 10 will be deleted. Next let us perform DEque operation one more time. So 0 plus 1 means 1. So 1 modulo. So after deleting this element, front is at this location. Okay. So 0 plus 1, 1. So 1 modulo 5 means 5. Okay. So now front is at first location. Okay. So let us perform DEque operation one more time. So what will happen? 20 will be deleted from the queue, and 1 plus 1 means 2. So 2 modulo 5 means 5. So now front is at the second location. Front is at the second location. Now let us insert two elements. So how we can insert the elements? We can insert the elements from the rear end. Okay. So what will happen now? In order to insert the element, we have to increment the rear. So rear plus 1 modulo size. So 4 plus 1 means 5. So 5 modulo 5 means 0. So now rear will be at 0th index. So that is the advantage of the circular queue. We can move from the last index to the 0th index. Let us insert some element here. And let the element is 50. Now let us perform NQ operation one more time. Okay. So we know that we can perform insertion operation from the rear end. Okay. So increment the rear value. So 0 plus 1 means 1. 1 modulo 5 means 5. So rear is at first location. So insert the value. So let us observe the circular queue now. So this circular queue is also full. So 0 contains 50, 1 contains 60, 2 contains 30, 3 contains 40, 4 contains 50. So what is front index here? 2. What is rear index here? 1. So that means if front double is equal to rear plus 1. So then also we can say that the circular queue is full. What is front? 2. So 2 double is equal to, what is rear here? 1. So 1 plus 1 means 1. So then also we can say that circular queue is full. So here we have two conditions. If one of that condition is true, then we can say that the circular queue is full. What is the first condition? Front double is equal to 0, double and rear double is equal to size minus 1. Or what is the second condition? Front double is equal to rear plus 1. So if one of these condition is true, then we can say that the circular queue is full. Okay. Let us write the code now. Here before performing the insertion operation, we have to check whether the queue is full or not. So if the queue is full, then we have to write one code. If the queue is not full, then we have to write one more code. Okay. First let us write the condition for full. So when we can say that the circular queue is full, if front double is equal to 0, double and rear double is equal to size minus 1. So this is one condition. Or what is the second condition? Front double is equal to rear plus 1. Front double is equal to rear plus 1. So if this condition is true, or if this condition is true, then we can say that the circular queue is full. So printf circular queue is full. So this is known as overflow. So what is overflow? Inserting an element into the queue if the queue is full. So if the queue is full, then if we try to insert the element, then we get the message here circular queue is full. So else, so what we have to do? Initially rear is at -1. Initially rear is at -1. But we have to insert the element at 0th index. So what we have to do? We have to increment the rear. But we have to go from 4 to 0 also. So the statement is rear is equal to rear plus 1 modulo size. Modulo size. Next read the value. So printf enter an item. Printf enter an item. Next read the item. So scanf %d comma ampersand item. Next store the item in the corresponding circular queue. So CQ of, here we are performing the insertion from rear end. So CQ of rear is equal to item. CQ of rear is equal to item. Okay. Next what we have to do? While inserting the first element, that means if front value is -1, then we have to place front at 0. If front double is equal to -1, then front is equal to 0. If front double is equal to -1, then front is equal to 0. So this is the logic. So let's check whether our logic is correct or not. Let the circular queue contains three elements. So size of the circular queue is 3. So we can have 3 elements from 0 to 2. So this is 0th element, 1 element, 2 element. So let us perform the insertion operation. Front double is equal to 0, rear double is equal to size -1. The initial values of the front and rear are -1. So this condition is false. Front double is equal to rear -1. So front value -1, -1 plus 1 means 0. So -1 double is equal to 0. So this condition is also false. So else block will be executed. So rear is equal to rear plus 1 modulo size. So -1 plus 1 means 0. 0 modulo 5 means 5. So rear is at 0th index. Next read the element. Let the element is 10. Next insert 10 at CQ of rear, CQ of 0. Next if front double is equal to -1. So what is the initial value of the front? -1. So front is equal to 0. So front will be at 0th location. Let us perform NQ operation one more time. So -1 double is equal to 0. So this is logical end. So if one of the condition is false, then the entire result is false. Front double is equal to rear plus 1. What is front value here? 0. Rear value 0. So this condition is also false. So if body won't execute, so else block will be executed. Rear is equal to rear plus 1 modulo size. So what is rear value? 0. So 0 plus 1, 1. So 1 modulo 5, 5. So rear is at 1 index now. So rear is at 1 index now. Okay. So what will happen now? Let the item is 20. So insert the item at CQ of 1. CQ of 1. Okay. Next front double is equal to -1. But what is front? 0. So 0 double is equal to -1. Condition is false. So this body won't execute. So this body will be executed only when inserting the first element. Okay. Next let us perform NQ operation one more time. Front double is equal to 0. So 0 double is equal to 0. And rear double is equal to size -1. But what is rear? 1. 1 double is equal to 2. Condition is false. So next front double is equal to rear plus 1. So what is front here? 0. So 0 double is equal to 2. So this condition is also false. So else block will be executed. So rear plus. Rear is equal to rear plus 1 modulo 5. So 1 plus 1, 2. 2 modulo 5, 2. So now rear is at 2 index. Let the item is 30. So insert 38 CQ of 2. Insert 38 CQ of 2. Okay. Now the next if front double is equal to -1. What is front value? 0. 0 double is equal to -1. So condition is false. So this operation is over. Let us perform NQ operation one more time. So what is front now? Front is at 0th location. What is rear now? Rear is equal to size -1. What is rear? 2. 2 double is equal to 3 minus 1. 2 double is equal to 2. So both the conditions are true. So we can say that this result is true. So circular queue is full. This message will be printed on the monitor. Okay. So in this way we can perform insertion operation. Now let's perform DEque operation. So we know what is DEque operation. So DEque means deleting an item from the queue. DEque means deleting an item from the queue. Here we have to delete the item from front end. We have to delete the item from front end. So let the circular queue contains 3 elements. 3 elements. So this is 0, this is 1, this is 2. Let we have 3 elements here. So 10, 20, 30. We know that front points to the beginning location, rear points to the ending location. Okay. Let's perform DEque operation. So we know that deletion operation will be done from the front end. So what will happen now? So front is at 0th location. What is the element here? 10. So 10 will be deleted from the queue. So deleted element from the circular queue is 10. Then after that, front value should be points to the next location. So we have to write the code as front is equal to front plus 1 modulo size. So 10 is deleted. So 0 plus 1, 1. 1 modulo 5, 5. So now here is at 1 location. I'm sorry, this is nothing but front. Let us perform DEque operation one more time. So what is the logic here? Front points to the 1 index. So deleted element from the circular queue is 20. And after deleting this element, we have to place front at the next index. 1 plus 1 means 2. 2 modulo 5 means 5. So now front is at 2 modulo 5 means 2. So now front is at second location. Okay. Now let's see the logic here. Now the circular queue contains only one element. That means front and rear are equal. After deleting this element from the circular queue, then the circular queue is empty. So if front double is equal to 0, if front double is equal to rear, then we can say that the circular queue contains only one element. So after deleting that element, the circular queue becomes empty. So if front double is equal to rear, then delete the corresponding element. And after that we have to place front and rear at -1. Front and rear at -1. Why? Because after deleting the only element, the circular queue becomes empty. So when the circular queue is empty, then the values of the front and rear are -1. Okay. So here we have 3 cases. The first case is when the circular queue is empty, and the second case is when the circular queue contains only one element. The third case is when the circular queue contains more than one element. Okay. So here the first condition is when the circular queue is empty, if front double is equal to -1, then we can say that the circular queue is empty. So display the message as circular queue is empty. Else if when the circular queue contains only one element, if front value and rear value are equal. So else if front double is equal to rear, then printf delete the corresponding element, and after that, after deleting this element, the circular queue becomes empty. So we have to place front and rear at -1. Next, else when this else block will be executed if the circular queue contains more than one element. So delete the corresponding element and increment the front value. So front is equal to front plus 1 modulo size. So let's write the code here. So before deleting an item from the circular queue, we have to check whether the circular queue is empty or not. So here the logic is if front double is equal to -1, if front double is equal to -1, then printf circular queue is empty. Printf circular queue is empty. So this is also known as underflow. Underflow means when the stack is empty, then if we try to delete an element from the circular queue, then the underflow condition will arise. Next condition, if the circular queue contains only one element. So when the circular queue contains only one element, if front and rear are equal, then delete the corresponding element. Printf deleted element is %d comma. We know that we performs deletion operation from front end. So CQ of front. Next, after deleting the element, the circular queue becomes empty. So we have to place front and rear at -1. So front is equal to -1, rear is equal to -1. So when this else block will be executed, when the circular queue contains more than one element, then print the corresponding element. Printf deleted element is %d comma. We know that we performs deletion operation from the front end. So CQ of front. Okay. Next, what we have to do? We have to place front at the next index. So front is equal to front plus 1 modulo size. So let's check whether our logic is correct or not. So let we have 3 elements. So 10, 20 and 30. 10, 20, 30. So 0 points to the front and front points to the 0 and rear points to the 2. So first condition, friend double is equal to minus 1. But what is friend? 0 double is equal to minus 1, false. Friend double is equal to rare. 0 double is equal to 2, false. So else block will be executed. Deleted element is, what is the deleted element? CQ of 0. What is CQ of 0? 10. So 10 will be deleted. Next, friend is equal to friend plus 1 modulo size. What is friend? 0. So 0 plus 1, 1. So 1 modulo 5, 5. So now friend will be at 1 index. Okay. Let us perform DEque operation one more time. Friend double is equal to minus 1. 1 double is equal to minus 1, false. Next, 1 double is equal to 2, false. Else block. Deleted element is CQ of 1. CQ of friend. CQ of 1 means 20. So 20 will be deleted. Next, friend is equal to friend plus 1 modulo size. 1 plus 1, 2. 2 modulo, here what is the size here? 3. So 2 modulo 3, 3. What is 2 modulo 3? 2. So friend is at 2 location now. Now friend and rare are at the same index location. Next, friend double is equal to minus 1. What is friend value? 2. 2 double is equal to minus 1. False. Next, else if friend double is equal to rare. 2 double is equal to 2. Condition is true. So deleted element is, what is the deleted element? 30 will be printed. Next, friend is equal to minus 1 and rare is equal to minus 1. So now friend and rare are at minus 1. Let us perform DEque operation one more time. What is friend value? Minus 1. Minus 1 double is equal to minus 1. Condition is true. So we got the message as circular queue is empty. So in this way we can perform DEque operation. Next, now let's see display operation. So by using display operation we can display the elements of the circular queue. So let's check the logic here. If friend double is equal to minus 1, printf underflow. That means the circular queue is empty. So this is the logic which we follow in order to display the values. But here what is friend value? 0. So 0 double is equal to minus 1. Condition is false. So else block will be executed. Next, code for I is equal to friend. So what is friend? 0. So I is equal to 0. Next, 0 is not equal to rare. What is rare? 2. So 0 is not equal to 2. Condition is true. So body will be executed. So CQ of 0. What is CQ of 0? 10. So 10 will be printed now. Next, I is equal to I plus 1 modulo size. What is I value? 0. So 0 plus 1, 1. So 1 modulo here size is 3. So 1 modulo 3. What is 1 modulo 3? 1. So now I points to 1. So once again condition will be checked. So 1 not equal to 2. 1 not equal to 2. Condition is true. So CQ of 1 will be printed. What is CQ of 1? 20. So 20 will be printed. Next, I is equal to I plus 1 modulo size. What is I value? 1. 1 plus 1, 2. 2 modulo 3 means 2. Now I becomes 2. So once again condition will be checked. 2 not is equal to, what is there? 2. 2 not equal to 2. 2 not equal to 2. Condition is false. So the control comes out from the for loop. But this element is not printed. So that's why we use one more statement in order to print rare value. Printf percentage d CQ of 5. What is a value? 2. What is CQ of 2? What is CQ of 2? 30. So 30 will be printed. So in this way we can implement circular queue. Now let's see about double-ended queue. In short we can call as DEque. D stands for double, E stands for ended, QE stands for queue. We know that in a normal queue we can perform insertion operation from end of the queue, that is nothing but rare end, and we can perform deletion operation from beginning of the queue, that is nothing but front end. Whereas in a double-ended queue we can perform insertion and deletion operation from front end as well as rear end. So here we have 4 operations: insertion at front, insertion at rear, as well as deletion at front and deletion at rear. Okay. Whereas in linear queue or in a normal queue, insertion should be done only from rear end. So insertion should not be done from front end. Okay. Insertion should be done only from rear end. Whereas deletion should be done only from the front end. So deletion should not be done from rear end. Whereas in a double-ended queue, double-ended, that means from the both the ends we can perform the operations. So from front end as well as rear end we can perform insertion as well as deletion operation. And here we can implement double-ended queue using 2 data structures. The first one is arrays and the second one is linked list. In this video, we will try to discuss about how we can implement a double-ended queue using arrays. In the next video, we will see how we can implement double-ended queue using linked list. So let's see the operations. Here, insert at rear end is nothing but normal queue insertion operation. Delete at front end is nothing but normal queue deletion operation. Okay, so these two are nothing but some extra operations which we are implementing here. So let us implement these four operations with the help of arrays now. Now let's implement the first operation, that is insert at rear end operation. So let us assume that we have a constant called size, and the value of the size is 5. Let us declare the size with the help of a macro. So hash define size 5. So throughout the program, size value should be 5 only. So it's not possible to change the value of the size. And then we have to declare an integer array. Int, let the name of the array is q. So int q of, so the size of the array is size. So before the functions, just we have to declare this macro as well as this array. Okay. So now let's perform the operation. We need to perform insertion operation at the rear end. So now let's take a queue where the size of the queue is 5. So we can have 5 elements from 0 to 4. So 0th element, next to first element, second element, third element and fourth element. So in this example, we have to perform insertion operation from rear end. The initial values of the front and rear are -1. Front always points to the beginning of the queue. Rear always points to the end of the queue. So here we need to insert the first element at 0th location. So in order to perform insertion operation at rear end, first we have to increment rear value. So -1 plus 1, so rear becomes 0. So now rear value is 0. Read an element and insert the element at the corresponding location, where the element is 10. Insert the element. We know that front always points to the beginning of the queue. So if front value is -1, then the queue is empty. So we have to place front at 0th location. Why? Because front always points to the beginning location of the queue. Let us perform insertion operation one more time with the help of the rear end. So we have to increment rear value. So now rear becomes 1. So rear will be at 1, whereas front will be at 0th location. So that the value is 20. So insert 20 at the corresponding location. Now let us perform insertion operation one more time. So increment rear value and insert the corresponding element at the queue. Let us perform insertion operation one more time. So increment rear value and insert the element at the corresponding location. Next, let us perform insertion operation one more time. So here the value is 40. Let us perform insertion operation one more time. So now rear becomes 4. So let the value here is 50. So now the double-ended queue is full. So when the double-ended queue is full here what is rear value? 4. What is size value? 5. So if rear double is equal to 5 minus 1 means 4. If rear double is equal to size minus 1, then we can say that our double-ended queue is full. Okay. So in this way we can perform the operation here. So here we have two cases. The first case is whether the circular queue is full, and the second case is the first case is if the double-ended queue is full. The second case is if double-ended queue is not full. So when double-ended queue is full, if rear double is equal to size minus 1, then we have to print the message as queue is full or overflow. So what is overflow? Trying to insert an element into the queue when the double-ended queue is full. Else read an element, insert the element at the corresponding double-ended queue, and if front is -1, then place front at 0. So let us write the code here. If rear double is equal to size -1, then printf overflow. So overflow means queue is full. Else what we have to do? We have to increment rear value, rear ++. Next to printf enter an element, printf enter an element, Next scanf percentage d comma ampersand element. Next, by using radiant, perform the insertion operation. So q of rar is equal to ELE. Next, if friend double is equal to -1, then what we have to do? Friend always points to the beginning of the queue. So friend is equal to 0. So in this way we can perform insertion operation. Now let us perform the second operation. So the second operation is deletion yet rar end, deletion yet front end. So delete yet front end, delete yet front end. So that is the second operation. Let us assume that here the size is 3. Let us assume that the size is 3. So we can have 3 elements from 0 to 2. So 0, 1, 2. Let the first element is 10, second element is 20, third element is 30. So we know that friend always points to the beginning index, rar always points to the ending index. So in this example, what is our target? We have to delete the element at the front end. Okay. So let's see what is the logic here. So deleted element from the queue is, so front is at 0th index, 10. So 10 will be deleted from the queue, and after that friend should point to its next location. So we have to increment friend value. So now friend becomes 1. Let us perform deletion operation one more time. So now friend points to 20. So deleted element is 20. So delete the corresponding element and move friend one position to the right. That means increment friend value. Okay. Next, friend is at 2 location, rar is at 2 location. That means friend and rar are equal. That means here the queue contains only one element. So if the queue contains only one element, then what we have to do? We have to delete the corresponding element. So deleted element is 30, and after that we have to place as friend and rar at -1 location. Why? Because after deleting the only element from the queue will become empty. So when the queue is empty, then we have to place as friend and rar at -1. So here we have 3 cases. The first case is if the queue is full. The first case is if the queue is empty. Why? Because we can perform deletion operation only when the queue contains some elements. If the queue is empty, then it is not possible to perform deletion operation. So the first case is if the queue is empty. So when the queue is empty, if friend value is -1, then we can say that the queue is empty. And the second case is if the queue contains only one element. So when the queue contains only one element, if friend and rar are equal. So else if friend double is equal to rar, if friend and rar are equal, then delete the corresponding element, and after that we have to place as friend and rar at -1 index. Okay. Why? Because the queue becomes empty after performing the deletion. Next, else perform the deletion operation and increment the friend value. So totally we have 3 cases. So we can perform deletion operation only when the queue is not empty. So write the first case. If friend double is equal to -1, then we can say that the queue is empty. That is nothing but underflow. So what is underflow? Underflow means trying to delete an element from the queue when the queue is empty, when the double-ended queue is empty. Else if, what is the second condition? If the queue contains only one element. So when the queue contains only one element, if friend and rar are equal. So if friend and rar are equal, then delete the corresponding element. So deleted element is %d comma q of. So what is the variable that we have to use as here? Q of friend. Why? Because we have to perform deletion from front end. So after deleting the only element, the queue becomes empty. So we have to place as friend and rar at -1. So friend is equal to -1, rar is equal to -1. Else, so when this else block will be executed, if the queue contains more than one element, then in that occasion display the deleted element. So deleted element is %d comma q of friend. Here the queue contains more than one element. So after deleting the 0th element, we have to delete the first element. So we have to place as friend at first location. So friend to ++. So this is the logic here. Now let's see whether our logic is correct or not. So here the queue contains 3 elements. Friend points to the 0th location, rear points to the second location. If friend double is equal to -1, 0 double is equal to -1, condition is false. So this condition will be evaluated. 0 double is equal to 2, false. So this block will be executed. Deleted element is, what is the deleted element? Q of friend. So 10 will be deleted. Friend plus plus. Now friend will be at 0 plus 1 means 1. Let us perform DEque operation, deletion operation one more time. So friend is at 1 index, there is at 2 index. So friend double is equal to -1. 1 double is equal to -1. False. So second condition will be evaluated. 1 double is equal to 2. False. So this block will be executed. Deleted element is, what is Q of friend? 20. So 20 will be deleted. Next to friend plus plus. So now friend will be at the second index. So first condition, 2 double is equal to -1. False. Second condition, friend double is equal to rear. 2 double is equal to 2. Condition is true. So deleted element is, what is Q of friend? Q of 2 means 30. So 30 will be deleted. 30 will be deleted. Next, friend is equal to -1, rear is equal to -1. Now friend will be at -1, rear will be at -1. Let us perform DEque operation one more time. Friend double is equal to -1. So under flow, Q is empty message will be printed. So in this way we can perform deletion operation at the front end. So now let's see about the third operation, that is nothing but insert at front end. Here we have three cases, when the Q is full, when the Q is empty, when the Q is not empty. Let's see the first case. The first case is when the Q is full. Let the size of the Q is 3, so that we can enter 3 elements into the Q from 0th index to the second index. So let we have 3 elements here, 10, 20, 30, where friend points to the 0th location and rear points to the second location. So in this example, our target is, we want to insert element at the front end, but before front. So we have to insert element at front. So before 0, we don't have any other location. So if friend double is equal to 0, then we can say that the circular Q, the double-ended Q is full. Okay. Here front means before front we need to insert the elements. If front is at second index, then before front the index is 1. So we have to insert element at the index 1. Suppose if front is at 100, then insert at front means before 100 we have 99 index location. So we have to insert the element at 99. But in the first situation, the front is at 0th location. But before 0 we have -1. But we don't have -1 here. The index starts from 0. So if front is 0, then we can say that the Q is full. So this is the first case. Second case, when the Q is empty. Second case, when the Q is empty. So when we can say that the Q is empty, if front is -1 as well as rear is -1, then we can say that the Q is empty. So if the Q is empty, in this example our target is we have to insert the element at the front location. So what is the initial value of the front? The initial index of the array is 0. So we have to increment front value. So that means -1 plus 1 means 0. So we need to insert the element at that 0th index. So here the Q is empty. So the front value is -1. So increment front and increment rear value. Okay. We need to increment rear also. Why? Because rear points to the end of the Q, whereas front points to the beginning of the Q. Okay. So if front is incremented, then front should be at 0th location. So in 0th location, insert the element. Okay. So this is the second case. So what is the second case? When the Q is empty. Now let's see the third case. The third case is when the Q is not empty. When the Q is not empty. That means when the Q contains some elements. Let we have 3 elements here. In the 0th location, in the 0th index, we don't have any elements. In the first index, we have 10. In the second index, we have 20. So front points to the beginning of the Q. That is nothing but front is at 1 index, rear is at 2 index. So here what we have to do now? Here the Q is not empty. Here the Q is not empty. So before this one, we have 0 here. So we have to place front at 0th location and we need to insert the element here. So how to get 0 from 1? So front is equal to front -1. So front is equal to front -1, and in the front location insert the element. Okay. So that means in 0th location we have to insert the element. So here the point is very simple. If the front is at the index 10, then we have to insert the element at 9th index. That's it. So let's see the logic here. So what is this logic? If the queue, when the queue is full, so when the queue is full, if friend double is equal to 0, then we can say that the queue is full. Okay. Next, else if, and what is the second case here? If the queue is empty. So when the queue is empty, if friend double is equal to minus 1, as well as if you want, we can also write it as and rare double is equal to minus 1. So then what we have to do? We need to place friend and rare at 0th index. So friend plus plus, rare plus plus. And insert the element at q of friend, q of 0. Why? Because here we are inserting element at friend with the help of the friend at, we are inserting the element. Else. So when this else block will be executed, when the queue is not empty, then what we have to do? We have to decrement the friend value, because friend is at 1 index. So we have to insert the element at 0th index. So friend to minus 1, friend to minus minus, and insert the element at q of friend. So in this way we can perform insert at friend end. Now let's see the last operation. Now let's see about the last operation, that is delete at rare end. Here we have 3 cases. The first case is when the queue is empty. The second case is when the queue contains only one element. The third case is when the queue contains more than one element. Let's see the first case. When the queue is empty. So when we can say that the queue is empty, if friend is minus 1 as well as there is minus 1, then we can say that the queue is empty. So if the queue is empty, then it is not possible to perform the deletion operation. So we can display the message as queue is empty or underflow. Underflow means trying to delete an element from the queue when the queue is empty. Okay. So this is the situation here. Here the size of the queue is 3. So we can store 3 elements actually, but queue doesn't contain any element. So we can display the message as queue is empty or underflow. Let's see the second case. When the queue contains only one element. So when we can say that the queue contains only one element, if the friend and rare are equal, if the friend and rare points to the same index, then we can say that the queue is empty. So what we have to do now? We have to delete that corresponding element. So after deleting that element, the queue should be empty. So when we can say that the queue is empty, if friend is minus 1 and rare is minus 1. So if the queue contains one element, here we have queue and the queue contains only one element, that element is at the index 1. So now the logic is we have to delete this element from the queue. So after deleting the element, the queue should be empty. So we have to place friend and rare at minus 1 indexes. Next, third case, when the queue contains more than one element. So when the queue contains more than one element, so what we have to do now? Here let the queue contains 3 elements. Friend points to the 0th index, rare points to the 2nd index. Here we are deleting the element at rare. So rare is at the 2nd index. So this element will be deleted. And after that we have to place rare at the 1st index. That is nothing but rare is equal to rare minus 1. So this is the logic which we have to follow. So let us write the code now. So first case, if the queue is empty. Second case, if the queue contains only one element. Third case, if the queue contains more than one element. So when the queue is empty, if rare double is equal to minus 1, as well as if we want, we can also write as double and friend double is equal to minus 1, printf underflow. So it is not possible to delete any element from the queue. Why? Because the queue is empty. Next, when the queue contains only one element. So when the queue contains only one element, if friend double is else if friend double is equal to rare, then what we have to do? Delete the element from the queue by using which end? Rare end. So printf slash and deleted element from the queue is %d comma q of rare. So what is q of rare? So 20 will be deleted from the queue. So after deleting this element, the queue is empty. So we have to place friend and rare at minus 1 index locations. Else, so when this else block will be executed, when the queue contains more than one element. So if the queue contains more than one element, then delete the corresponding value. So deleted element from the queue is 30 and we need to place rare at minus 1. So rare is equal to rare minus 1. So in this way we can implement double-ended queue with the help of arrays. In the next video we will see how we can implement double-ended queue with the help of linked list. Now let's see about double-ended queue using linked list. In the last video we have seen about implementation of double-ended queue using arrays. Okay, let's see what is a double-ended queue. In a double-ended queue we can perform insertion and deletion operations from both the ends, from front end as well as rear end. Whereas if you take linear queue, we can perform insertion operation from rear end, whereas deletion operation from front end only. Okay. Whereas with the help of double-ended queue, we can perform both insertion and deletion operations from the front end as well as rear end. So here we have 4 operations. The first operation is insert at front end, insert at front end. The second operation is insert at rear end, insert at rear end. Third operation is delete at front end, whereas fourth operation is delete at rear end. Whereas if you take a normal queue or linear queue, then we can perform only insertion at rear end as well as deletion at front end. Whereas in double-ended queue, we can perform insertion and deletion operations from both the ends, from front end as well as rear end. Here we are implementing double-ended queue with the help of linked list. Here it is better to use double linked list in order to implement a double-ended queue. We know what is a double linked list. It is a collection of nodes where each node contains 3 fields: previous field, data field and next field. Previous field contains address of the previous node, data field contains data of the node, whereas next field contains address of the next node. Okay. In a double linked list, the first node previous field and the last node next field contains null value. Here, before performing these 4 operations, it is better to create a double linked list and write a display function for the double linked list. So after performing creation and display function, we need to implement these 4 functions. Okay. First, let us write the node representation. Let name of the node is node. So struct node. So it has 3 fields. The first field is previous field. So struct node previous field. So star prev. It contains address of the previous node. Second field, data field. It contains data of the node. Next field. It contains address of the next node. And here we are using 3 structure variables. The first one star new, second one star friend, third one star rear, and the fourth one star temp. So totally we are using 4 structure variables. So first one star new, it is for allocating memory for a node. Next star friend. Friend always points to the starting node of the list. Next one star rear, it points to the ending node of the list. Star temp, it is for traversing from one node to the another node. Okay. Here the default initial values of new, friend, rear and temp are null. Why? Because the structure will be defined on top of the main function. Okay. And in the main function we define the functions with the help of some while loop. Okay. In the first case call create function, in the second case call display function, third case insert at front function, in the fourth case call insert at rear function. Likewise we can call the functions in the main function. So let us define the first function, that is create function. Okay. Create function. First let's see the logic for the create function. First we have to allocate memory for the node. In order to allocate memory for the node, here we have to use new. We know that the node contains 3 fields. So let the name of the node is new. Let the address of the node is 1000. So first allocate memory for the node. Then after that store null in previous field. Read a value and store value in data field. And store null in next field. Next we have to check whether the list is empty or not. So when the list is empty, we know that here we are using a structure variable called friend. So friend always points to the beginning of the list. So if friend value is null, then we can say that the list is empty. The initial value of the friend is null. Why? Because that structure was defined on top of the main function. So initially the friend is null. So we can say that the list is empty. So if the list is empty, then what we have to do is we have to place friend and rear yet the new. So place friend and rear yet the new. Okay. Then after that, let us create one more node. So name of the node is new. So this will be erased. Let the address of the node is 2000. It has three fields. In the first field store null value. In the second field store data. Let the data is 20. In the third field store null. Next we have to establish connections from first node to the second node and second node to the first node. The first node next field contains address of the second node. So in this null we have to store 2000. So how to store 2000 here? Here we should not use friend here. Okay. Here we have to use where, because where always points to the end of the list. So initially this is nothing but the end of the node, end of the list node. Okay. Next, if there are two nodes, then this node will become the last node. Okay. Where always points to the last node. So in order to establish the connections, we have to use where. We should not change friend. Friend always points to the beginning node of the list. So rear arrow next is equal to new. So in rear next we have to store new. So that element will be formed like this. So next what we have to do? So this node previous field is this address. So we have to store this 1000 here. So if we store 1000 here, then element will be formed like this. So we can write as new arrow prev is equal to rear. New arrow prev is equal to rear. So don't use friend. Okay. Why? Because after that we have to establish the connection from second node to the third node. So now rear is at the second node. Okay. Whereas friend is at the first node only. So we have to write as new arrow prev is equal to rear. Okay. So that if you store here, then element will be formed like this. Next, move rear one position to the right. So we can write as rear is equal to rear arrow next, or rear is equal to new. So that now rear will be at this position. Okay. So likewise we have to write the logic. So let us write the logic for creating a double-ended queue. Here we have to repeat the loop as long as we enter while. So use some do while do. So first we allocate the memory for the node. So new is equal to struct node star malloc of size of struct node. Malloc of size of struct node. So allocation of the memory is over. So next what we have to do? We have to store prev in null. Next, so allocation of the memory is over. So what is the node name? New is the node name. So it contains three fields. So 1000 is the address. So first we have to store null in previous field. So new arrow prev is equal to null. So store null here. Next, read a value and store value in data field. So printf enter a value. Next, scan of %d comma ampersand value. Next, we have to store value in data field. So here the statement is new arrow data is equal to value. So let the value is 10. So 10 will be stored in new data now. Next, in the next field, store null. So new arrow next is equal to null. So store null here. Next, we have to check whether the list is empty or not. So when the list is empty, if friend is null, the default initial value of the friend is null. So if friend double is equal to null, the initial value of the friend is null. So what we have to do? We have to store friend and rear at new location. So friend is equal to new, rear is equal to new. So friend and rear are placed at 1000 location. So friend is equal to new. Next, rear is equal to new. So this is the first case. The second case is if the list is not empty. That means here the list is not empty. Why? Because friend contains 1000. So let us create one more node now. So let the address of the node is 2000. So it has two fields. So name of the node is new. So this node no longer available. Okay. Now what we have to do? Now, so allocation of the second node is over. Next, store null here. Next, let the data is 20. Store 20 here. Next, store null here. So now what is friend value? Friend value is 1000. 1000 double is equal to null. Condition is false. So else block will be executed. That means here the list is not empty. So if the list is not empty, then what we have to do? We have to establish a connection from first node to the second node and second node to the first node. So this is nothing but first node next field. Store new address here. New address means 2000. If you store 2000 here, then link will be formed like this. So here we have to write the statement as rear arrow next is equal to new. Rear arrow next is equal to new. Next, this node, previous node is this node. So what is this previous node address? 1000. So store 1000 here. So if we store 1000, a link will be formed like this. So we have to write as this is nothing but previous field. So new arrow prev is equal to rear. So we have to use rear only. Don't use front. So new arrow prev is equal to rear. Okay. Next. So printf, write the condition. Printf, do you want to add one more node? Printf, do you want to add one more node? One more node. So we have to enter either y or n. So y stands for yes, n stands for no. So scanf %c comma ampersand ch. Ampersand ch. Next here we have to repeat the loop as long as we entered y. Ch is equal to y. Okay. So second node creation is over. So now next what we have to do? Printf, do you want to add one more node to the list? So it will be executed. So let us assume that we entered y. So now ch contains y. So y double is equal to y. Condition is true. So one more time body will be executed. Okay. So what will happen now? One more node is created. So new. Let the address of the node is 3000. Let the node contains 3 fields. Okay. Next, allocation. Allocation of the memory for the node is over. Next, store null in previous field. Store value in data field. Store null in next field. So store null in previous field. Let the data is 30. Store 30 in data field. Store null in next field. So next condition, if friend double is equal to null. Now what is rear now? Rear arrow prev is equal to now. So after creating the second node, this node will becomes the end of the node. So we have to place as rear at 2000. So we have to write one more statement here. So rear is equal to new. Rear is equal to new. Okay. So what is new? 2000. So rear will be placed at 2000 memory location now. Okay. So friend always points to the beginning node, rear points to the ending node. Okay. But after creating the third node, this node will becomes the rear node, end node. Okay. So friend double is equal to null. What is friend? 1000. 1000 double is equal to null. False. So else block will be executed. So what is the first statement? Rear arrow next is equal to new. So what is new? 3000. So store 3000 in rear next. So that a link will be formed like this. Next, new arrow prev is equal to rear. So what is rear? 2000. So store 2000 in new previous field. New previous field. So that a link will be formed like this. Next, rear is equal to new. What is new? 3000. So place rear at 3000 location. Next, printf, do you want to add one more node to the list? Let us assume that we entered n. Now ch contains n. N double is equal to y. Condition is false. So the control comes out from the list. So in this way we can perform creating a double-ended queue. Now let us perform display operation. After that we will write those 4 functions. Okay. Now let's perform display. Displaying the double-ended queue. Display. Let our double-ended queue contains 3 nodes. So this is the first node, second node, third node, where address of the first node is 1000, second node address 2000, third node address 3000. So it has 3 fields. So every node contains 3 fields. Every node contains 3 fields. Data of the first node 10, let data of the second node 20, data of the third node 30. So this is the first node. So the first node previous field will become null. Next, first node next field means 2000. So if you store 2000, a link will be formed like this. Second node previous field is 1000. So store 1000 here. Next, second node next field contains address of the third node. So store 3000 here. So that a link will be formed like this. Third node previous field contains address of the second node. So store 2000 here. So that a link will be formed. And the last node next field contains null. So friend points to the beginning of the node, beginning of the list, whereas rear points to the end of the list. Okay. Next, initially place temp at front location and check whether it is not equal to null or not. If it is not equal to null, then display the corresponding data. So likewise we have to repeat the loop as long as temp is not equal to null. So here the logic is very simple. So temp is equal to friend. So temp is at 1000 location now. Next we have to repeat the loop as long as temp is not equal to null. So while temp is not equal to null, then display the corresponding data. So printf %d, give some space here, comma, temp arrow data. Next we have to traverse to the next node. So we can traverse to the next node with the help of temp is equal to temp arrow next. Temp is equal to temp arrow next. Okay. So initially temp is at friend, while temp not equal to null. What is temp? 1000. So 1000 is not equal to null. Condition is true. So print 1000 data. What is 1000 data? 10. So 10 will be printed. Now after that some space will be printed. Next once again condition. Next temp is equal to temp arrow next. What is temp? 1000. 1000 next means 2000. So now temp will be at 2000 memory location. So once again condition will be evaluated. What is temp now? 2000. So 2000 is not equal to null. Condition is true. So what is 2000 data? 20. So 20 will be printed. Next to temp is equal to temp arrow next. Temp means 2000. So 2000 next means 3000. So temp will be placed at 3000 now. Next, why temp not equal to null? 3000 is not equal to null. Condition true. So what is 3000 data? 30 will be printed. Next temp is equal to temp arrow next. What is 3000 next? Null. So now temp will become null. Temp will become null. Null not equal to null. Condition is false. So the control comes out from the corresponding while loop. So in this way we can print double-ended cube elements. Now let us perform the 4 operations one by one. So what is the first operation? Insert at front end. Second one, insert at rear end. Third one, delete at front end. Fourth one, delete at rear end. So first one, insert at front end. So let us perform this operation first. So let the double-ended queue contains 3 nodes. So first node, second node, third node. So address of the first node 1000. Node contains 3 fields. Address of the second node 2000. Node contains 3 fields. Address of the third node 3000. Node contains 3 fields. So 10, date, 20, 30 is nothing but data of the node. First node next field contains, first node previous field contains null. Last node next field contains null. So it contains address of the next node 2000. It contains address of the previous node 1000. It contains address of the next node 3000. It contains address of the previous node 2000. Next friend points to the beginning of the list, that is nothing but 1000. Rear points to the end of the list, that is nothing but 3000. So in this example our target is we want to insert element at front end. So let the element is 40. So after inserting 40 at the front end, the output is 40, 10, 20 and 30 is the output. Okay. So first what we have to do, we have to allocate memory for the node. Here we are allocating, we are inserting at front end. So at the beginning position create the node. So node contains 3 fields. Let the address of the node is 4000. Next what we have to do, so before this node we don't have any other node. So store null here. Next read a value and insert value in data feed. Next what will happen, after inserting this node will become the first node and this node will become the second node. So this node next field contains address of the next node. So we have to store 1000 here. So let us write the code in steps. So new is equal to struct node star. New is equal to struct node star malloc of size of struct node. So allocation of the memory is over. Next to store null in previous field. So new arrow prev is equal to null. Next read a value. So printf enter a value. Next scanf %d comma ampersand value. Next store value in data feed. So new arrow data is equal to value. So next after inserting this node will become the first node. So what we have to do, we have to store this 1000, we have to store this 1000 here. Okay, we have to store 1000 here. If you store 1000 then a link will be formed like this. So this is the new connection. So that's why use some dotted arrows. So we can write as new arrow prev is equal to front. New arrow, this is previous field or next field? This is next field. So new arrow next is equal to front. So store front address in new next field. Next, what is the next statement? So after inserting first node, this node will become this second node. Okay. So we have to store address of 4000 in this friend. So store 4000 here. So if you store 4000 here, then a link will be formed like this. So this is nothing but front node. So front arrow. This field is nothing but previous field. So front arrow prev is equal to new. Okay. So next, what we have to do? After inserting this node, this will becomes the first node. So front always points to the first node. So we can write the statement as front is equal to new. Front is equal to new. So what is new? 4000. So we have to place this front at 4000. So now it will becomes the first node. Okay. So in this way we can perform insertion at front end. Now let us perform the second operation. So what is the second operation? What is the second operation? Insert at rear end. Insert at rear end. So let the list contains 3 nodes. So what is the first node? Previous field null data. Here we have some 2000. So this is nothing but front. So in this example, what is our target? We want to insert the element at rear end. So let the element is 40. So after inserting the node at rear end. So rear means ending. So then what will happen? The output is 10, 20, 30, 40. So we have to insert the element here. Rear means end of the list. So name of the node is new. So first allocate memory for the node. So allocation of the memory is over. Next, store null in previous field. So new arrow prev is equal to null. Next, store data in value field. Let the data is 40. So store 40 here. Next, store null here. Okay. Store null here. Here in place of this, it is better to store here. There is no need to write the statement. Why? Because after inserting this node, so this node will become the last node. So this is nothing but the previous node. So we have to store 3000 here. So if we store 3000 here, then what will happen? A link will be formed like this. So we have to write the statement as new arrow prev is equal to rear. New arrow prev is equal to rear. So store 3000 here, so that a link will be formed like this. Okay. Next, new arrow data is equal to value. New arrow data is equal to value. So let the value is 40. 40 is stored here. What is new arrow next? New arrow next is equal to null. So till now, allocation of the memory is over. Next, in previous field, store address of the previous node 3000. So new arrow prev is equal to rear. Next, store value in data field. Next, store null in next field. Okay. So next, what we have to do? We have to, after inserting this node has to become the last node, and this node has to become the last buffer node. So in place of this null, we have to store this node address. Let this node address is 4000. So if we store 4000 here, then a link will be formed like this. So we have to write the statement as rear arrow next is equal to new. So in rear next, store new address. Next, after inserting this node will become the last node. So we have to place rear at new position. So the statement is rear is equal to new. So in this way we can insert an element at rear position. Now let us perform the third one, deletion at front end. Now let's see about delete at front end. So we have a double-ended queue like this. So front points to the beginning node and rear points to the ending node. So in this example, we have to delete the element at the front end. So we have to delete this 10 node. So after deletion, the output is 20 and that is the output. Okay. So what we have to do now? Initially, we have to place this temp at front. So temp is equal to front. Temp is equal to front. Next, display the deleted node data. So printf deleted node is %d comma front arrow data. Front arrow data. Okay. So what is the deleted node now? 10. So 10 will be printed. So after deleting this node, so what will happen? This node will become the first node. Why? Because we are deleting this node. So we have to place front at the next location, that is nothing but 2000. So we can write as front is equal to front arrow next. So what is front? 1000. What is 1000 next? 2000. So front will be placed at 2000 now. So after deleting this node, then this node will becomes the first node. So in the first node previous field, we have to store null. So front arrow prev is equal to null. So store null here. So if you store null here, then this link will be broken. So likewise we have to break this link also. So write the statement as temp arrow next is equal to null. Temp arrow next is equal to null. So store null here, so that this link will also be broken. Next, there is no need of this memory. So in order to release the memory, use free function. So free of temp, so that this memory will be destroyed. So this memory will be useful in order to store some other node. So in this way we can perform deletion at front end. Okay. So front is at the second node. After deleting this node will become the first node. Now let us perform the last operation, that is nothing but delete at rear end. So in this example we have to delete the element at the rear end. So this is the first node and this is the last node. So we have to delete this node. So the deleted node is 13. So after deleting the last node, the output is 10 and 20. So let's see what is the logic here. So after deleting this node, so what will happen? This node will become the last node. So initially place temp at rear. Initially place temp at rear. Next to delete the display the deleted node. So printf deleted node is percentage d comma deleted node is percentage d comma rear arrow data. So now 30 will be printed. Next, after deleting this node will become the last node. Okay. So we have to place as rear at 2000. So how to place rear at 2000? So 2000 is nothing but rear previous field. So rear is equal to rear arrow pre. So what is rear pre? 2000. So rear will be placed at 2000 now. So after deleting this node will become the last node. We know that the last node next field contains null. So store next in the last node next field. So rear arrow next is equal to null. If you store null here, then what will happen? This link will be broken. This link will be broken. Then after that, here also store null, so that this link will be broken. So we can write the statement as temp arrow next is equal to null. Now there is no need of this node. So destroy the memory with the help of the free method. So free of temp. So in this way we can implement double-ended queue with the help of double linked list.